Get a concert. Can you turn it? Oh, now I can hear it. Okay, turn on my monitor. Okay. Hey, everybody. Welcome back. Those of you that came back. Wow. That's and what a ringing endorsement that we have so many people that returned for the second day. So that's good. All right. So welcome to day two. The first thing we're going to do at day two is we're going to do a recap of yesterday. And this is not just well, it's nice because it kind of gives us a review of what we did. But what I'm looking for, particularly on the Foxborough roadmap stuff, is where you guys might have had some questions or comments after thinking about it last night. So it's a chance for us to, you know, get those questions in before we keep going too far. So Thad and Marcel in the back, you guys might get called on because I'm about to run through a lot of stuff that y'all said yesterday and then just be like, okay, everybody good with all this? So like recap, I'm just recapping what you did yesterday. So here we go. I remember today like it was yesterday. I didn't drink too much last night, so I remember pretty much all the stuff. Let's see. We got to skip another slide. Where are my slides? There we go. Thad Frost's hardware roadmap, page one. Thad got the ball rolling yesterday, and he talked about the computers. And he said we're going to have a Dell Precision 5860 and a HP ProLiant, and that you said that the thin client was probably going to only last for another year or two. Is that an accurate recap, Thad? Okay, good. And then the root switches, we have the extreme, root switches, edge switches, high temperature switches, and then I wasn't really clear where the Hirschman Greyhound fell into that, but it's listed under your switches. Page two, the FCP 280, that's going to be around for the foreseeable future. I didn't see anything. And you said you're making sure you can get parts, and there might be a respin on that, but functionally, no changes on an FDC 280. DCS migrations, you still got a Bailey 90, an Infa 90, and a Honeywell TDC 3000. Those are our migration packages that y'all are offering, right? Control hardware, universal IO, you've got some predefined enclosures with FBM 247s, 248s, an i20, which has got 64 IO, and an i30 with 448. Maybe. And then we have an electrodynamic controller, which has got the native 61850 Goose protocol for use in substations, and it runs IA blocks in it. I was going to type all that, but no, I'm not going to type all that. You guys got to. What's that? Thanks, Unc. It's okay, little bro. We'll work that out. Let's see. We got that. So then the next part was the Edge IO. We've got a new system communication module, the SCM, and that is going to be the migration path forward to get rid of the ZCP270s. And it's the eventual replacement for your FCMs, which are your field bus communication module or field communication module. Yeah. Right. Right. Okay. Okay. Well, that,
We don't want it like 6.5, 3, 4, 5. They came out like real quick, where it's 8 microns. Let me check that we already support that. I just don't know. We just ran a brand new mesh check. We just started getting it back. We were so far away. So the mesh. We're just switching.
Well, Ryan, if you'll remind me, I'll make a note. I mean, because what I would like to do with all these, and one of the reasons I'm running through them and questions from the audience and getting you cleared up is we'll write this back up and put it out on the list. This is part of the stuff that it helps a lot to kind of put it all into a bullet points. Okay. And then we got into Marcel's the software roadmap. Was there anything else we left out of the hardware, Thad, that you felt like was yeah, I mean that's part of the whole like setup, but yes, we got the, well actually I don't think I got it in the slides, so we probably need to capture that. But the FDSI and redoing a next generation FDSI discussed yesterday. Any thoughts on that from the audience? Anybody got questions, concerns?
Still doing the 233, 230.
Yes, agreed.
Red, and I had to redo the base plate.
Yes, agree, also agreed. That's a big deal. I think that nobody's against it, right? I mean, yeah, that's definitely what we want. So that's good. I think there are places where it makes a lot more sense to use it. One, you can put a lot more blocks in it than you can in an FDSI. You have the ability to run multiple protocols in an FDC 280 that you can't do in an FDSI. I mean, if you had a CP and an FDSI on a 2-slot base plate and you had them in a control room and you were only using that CP to do connectivity to a PLC or whatever, which we see people do that. In that instance, I think it makes a lot of sense to go to a FDC 280 because it's a better replacement for that application. But if you've got the FDSI out in a remote field enclosure, you know, far from the CP, if you've mixed and matched blocks where you got analogs that are, or whatever, any kind of IO that's not the soft IO going through the gateway, then no, it's not a good replacement for that. So
It's also the only thing that's
that's also the thing that's available in the next 2 years. So you got that going for you. Yes, and you trust that, and you are going to be there in 2 years, and you feel like, you know, this. I mean, I'm sure that it'll. Well, yeah, they guaranteed it. I mean, I think it'll be there. I'm sure that, you know, their time frame may hit some snags as they go through there and develop it. So you might want to be. I'm trying to help you. I'm not committing you to this, so you're you know, don't. So an online upgrade, the enhanced online upgrade for an FDC 280. Yeah. Yeah. So I still think that there's a place, and yeah, that it makes a lot of sense to have an FDC 280 in a lot of instances. Okay. Then we got into Marcel's Foxborough software roadmap. And Marcel is the software offer manager and our man in Dusseldorf. And it seemed like a lot of things are being driven by the Cyber Resiliency Act coming out of Europe, and that's fine. That makes sense. If they're going to sell in there, they've got to do that. And then on the ICC, and this has been the case for years, no surprise there, right? They're not making any enhancements to the ICC. IACC, they're not going to support after October of 2026, so you need to migrate away from that. Yesterday, we didn't have anybody in here that had IACC or was still using it. I know a couple of facilities that aren't here, but they can, you know, figure out what to do with that. And then on the control editor, and this is a question for you, Marcel. We're at version 8.1 now, and version 8X comes out when? When's the next version of the control editor coming out? Okay. With coming out with the Q4 2027. Right. I knew that you were trying. I know that you were trying to hit that CRA compliance there. Yeah.
Just a little typo. IACC, not AICC, right? So if you're an IA UNC, please use IA, not AI. AI is
it's the artificial intelligence control configurator.
It's an AI powered ICC. Maybe there's an interest for that. Who knows?
All right, and then for FoxView, it continues to be supported, but no enhancements. Control HMI, we've got the InTouch Industrial Graphics, formerly Orchestra Graphics. That's still the normal thing that we've got in our Control HMI. The Wonderware OMI won't be a factor until you go toward into the SDA stuff, and at that time, your InTouch graphics can be rolled up into the OMI. So that's not a big problem. It just gives you more features that the OMI has when you get to the SDA. And then Schneider is working on a better conversion tool from FoxView to Control HMI. That pretty much the visualization part.
So minor thing, we should be all clear. Wonderware is dead, right? It's supposed to be Aviva InTouch OMI. So everything is Aviva these days.
Right.
But yeah, that's okay. Concerning FoxView, we are still debating if this is brought to CRA compliance. I would love to do so. So the intention is to do that. If we do that, we have to modify some of the functions, obviously. So no enhancements is a little bit too strict, right? It's an available lifecycle phase, which means innovations are primarily focused on the follow-on product. But until we stop selling it, we might touch it. So it's not like there's nothing happening ever.
Right. Yeah. Well, when I say no enhancements, I mean those are the you're not going to add new features. You're just going to, if we have to fix a bug or there's a security patch or something like that, those things are still being included and fixed in FoxView Foxdraw.
Right.
Yeah, and that's what we've seen. I think that matches what everybody was expecting. So I don't think we've get no surprise from that based on what we've done. The OPC UA server was released in March of 2025. They're doing a lot of enhancements to OPC UA. You have an OPC UA client on the FDC 280. We touched on that. So I think we're good there. And then the software-defined automation, that was by Baljit, and he presented that. And that's Schneider's vision of the future. This is still, they have some parts and pieces that they've kind of got here. They're showing us how it looks and how they're going to go forward from there and how you would get your Foxborough control system to migrate over into a software-defined automation future. Good. All right, that was good. Let's see if we got anything else. Yeah. And then the next thing we saw yesterday after your presentation and Baljit was we saw the Talsoft. They did the T-Star, and that was their software package, and it was a very comprehensive tool. It looked like they could do data analysis, reporting, trending. They had a web view only display service where they took the graphics and created those and put them out as a web based thing for read only, which was nice. And then they had a whole suite of tools included with that that was similar to the things you might see in the Foxray and system editor, in addition to all of those other tools that were part of the package. So they've got a whole lot of stuff wrapped up in there, and they've got a booth out here, and you can see them and talk to them. They're going to be doing another demo on some different stuff today. And then we did the FDC 280 with the implicit communication with David McCullough. And that he was showing that we could talk directly without having a PLC up here to the Rockwell PowerFlex drives. And we did have one up here. We've done two different ones, a 500 series and a 700 series in the office. And we know they work. They're slightly different configurations. We did an E300 starter, and we did a Schneider Electric T-Sys-T motor starter. So all of those using just the native Ethernet IP stuff with no PLC in it, and we're able to drive directly to those. So that's kind of a new thing for us, and that's good. And then I think after that, I did a couple of things, and that was pretty much yesterday's rundown. Now, did anybody have anything that they feel like after, thinking over it last night, have any questions or comments about yesterday's, agenda, things we did, things you want to see before we get into today's topics? No, that's good. All right, then the next speaker will be from Aviva, and it is how to connect industrial cloud platform to your IA system. And it's going to be presented by this gentleman over here, whose name escapes me because it's not on my list up here. And let you get your, here's the, if you want to use the clicker. That.
Good morning, everybody. My name is Brian Martin. I think that's up there, right? I'm a technical sales consultant with Aviva. From my background is I came from Wonderware. So when I hear the term Wonderware, I like to hear that because it's been around for quite a while. So I started with Wonderware back in the 90s and moved through all the different iterations of the products and how Wonderware was acquired. I do just want one kind of a clarification on the last conversation. I know that Foxborough uses Aviva software. It's built into the control software. There's a lot of times I hear some kind of confusion between InTouch and OMI. So they are two separate products. So a lot of times you hear InTouch OMI. There's really no such thing as InTouch OMI. InTouch is a container that hosts those industrial graphics, or orchestra graphics was the previous term for those. InTouch hosts, so does OMI. They are two different packages. They host the exact same graphics. They kind of do the same thing. OMI is a more modern platform, so it has a lot of contextual awareness of the model that was generated in what we call system platform. So from a graphical standpoint, it's the same graphics in both of those products, but they are two separate interfaces, and most of you are probably more familiar with the InTouch interface because that's been the common interface that's been used in the Foxborough products. So I just kind of wanted to bring that up because I do see it a lot, and I just wanted to try and clear that up a little. So what I'm going to do is I'm going to talk about the cloud. How many of you are using the cloud for your industrial spaces? That's kind of exactly what I expected to see. So Connect is not a new product. We've had a software as a service product from the Viva offering for almost 15 years now in various versions of that. So Connect is our basically our latest software offering for the cloud. It's everything cloud from Aviva falls under the Connect umbrella. So when you look at what Connect is, Connect allows you to bring information from all kinds of different sources into one central location. In this case, it's in the cloud. There's no infrastructure required by the end user to utilize Connect. It's all in the cloud. You don't have to stand up any servers. You don't have to worry about securing a network, none of that stuff. It's all in the cloud. It's all hosted by Aviva. So if you look at that Connect piece and you look at some of the pillars, and I like the Wonderware logo is still there, but if you see those logos, when we developed Connect, what we wanted to do is bring all of our products together into one central location in the cloud. So Aviva already had products from an engineering standpoint, 3D modeling, P&ID drawings, all of that type of product was built into the Aviva product. Wonderware had an industrial SCADA system and all of the pieces around the SCADA applications. And then when we acquired Pi, we acquired all the Pi historians, and even though we already had a historian with Wonderware, as far as the EcoStruxure and Schneider Electric, that's all available to be sent up there as well as third-party information. So we've got REST APIs, connectivity, and publishers that you could just publish stuff direct from OPC UA, direct from Modbus, direct from Rockwell protocols, and have that sent automatically up to the cloud. And when I say sent up to the cloud, it is just it's an outbound connection. So we're not talking about, connecting a platform. We can actually jump through gateways in order to get it up through what we call a secure DMZ link to send the data out. But we send all this data out to the cloud, and then once it's there, you can build visualizations around it, build enterprise visualizations around it. You can share data. You can now start to take advantage of a lot of the things that are available from a cloud standpoint. You can start to interrelate that data. And that's one of the things I mentioned about system platform and that context in OMI, because it's contextually aware. And what that means is when you have an OMI application, you can have the context of, hey, I just selected a tank. Now I know that I've selected this tank. I also want to see the 3D drawing for that tank. I want to see the 2D P&ID drawing that's available. I want to see the maintenance information. I want to see the, all these different data points being brought together, adding the context around that piece of equipment. So what that enables you to do is basically have a single source for people to be able to go get this information. Now, I've seen a lot of customers over the years that, and I've heard it over and over again, yeah, we're never going to do anything with the cloud, but it's happening no matter what. But being able to have all this information in one place, and I actually have two customers that I kind of follow their application of our cloud services, and I go look and I see that their ramp up of the users on their cloud goes up every month, meaning the people that are using it use it more, or newer people start using it that weren't using it before, because now they have access to all this information that they could never get to without going to the HMI SCADA system or requesting it from somebody else. So they have actionable insight now, and they can make decisions without having to involve a lot of other people in those decisions. And they've also got this unified experience. So everybody who's looking at this information has the same view and the same context of all of that information. The other piece that one of the two main customers that I follow, and we have hundreds of them, one of the other things that they're doing is they need to share that data with other organizations outside their organization. So we have the this concept of communities. And a community allows you to say, hey, this information is important to maybe this OEM that built the piece of equipment, maybe a supplier that supplies the raw material that's coming in, and I can build upon this ecosystem to give people access to that information. Now, again, this is all cloud. So there's, as I mentioned, there's no infrastructure required. You simply sign up for the cloud service from a licensing standpoint. It's based on users and streams. We'll stay away from all that complicated stuff at the moment. But what I want to do today is kind of focus on 3 of these main platform services. Now, I did mention that Connect is our total cloud platform. So everything that we do from a Viva standpoint, cloud, is part of Connect. So if you go to connect.aviva.com, that's everything that we do will be in that one place. I'm going to kind of focus on this data services and the visualization services and just give you a few examples of those things. So you log into Connect just like any other website. So you can go to connect.aviva.com and change the URL after you put it in there, but you'll be at our industrial portal. So Connect is our industrial portal. And then you'd have access to all of the different services that are available in that industrial portal. So if you go to connect.aviva.com, it's going to look like this. It's a website, a menu across the top. It's got a button to sign in. It's got some other information that you can go check out without being signed in. So you can see some of this information without being signed in. So if we just take a quick look, I can see all the use cases, data management. We have customer testimonials up there, different resources as far as those, a learning academy, so you can do all of the learning stuff online. And then if I go ahead and sign in, because we can federate this, it's federated with your Microsoft login credentials. So you can see it's using my aviva.com credentials. I don't have to have a separate username or password. That's all managed by my IT department. Typically, you don't have a big list of things like this, but I have a lot of demos. So when you go ahead, and most people might only have one of those folders that they have access to. But when I go ahead and select something like that, actually, stop this right here for a second if I can. Once I log into this, I now have access to everything that we make available, and this can all be organized based on folders. So I can create all these different folders and then take all of the different cloud tools that we have available in Connect and make them available to users. So a user would log in here, and if a user is using our Edge management where they're pushing down an Edge application, an Edge control application, they could log into the Edge management just by clicking on that Edge management tile. But again, everything here is managed from here. So you can see all those different applications that are available. If I go up to the folder management, that's where I would just create these different folders where I can organize things and give people different access to these folders. I can do my user management from here. So I do all my user configuration from here. I can do the roles. I can do an import. So if I'm using, your Active Directory from your Microsoft Active Directory, I can import all those users, that federated connection. All of that stuff is connected automatically. I can do the reports on users. And this is one of the things I mentioned about that customer that I look at. As I go in and I look at these reports based on the users and the time that they're using it, and that's where I can see and actually feed back to the customer who sponsors, the user who sponsors this at the company, that, hey, look at all this, look at how much your usage is going up. So I think that's the end of that video. So what I wanted to do is, as I mentioned, I wanted to focus in on data services and visualization. So I kind of selected a fictional company that we have in here called Intelliv, and this company has a lot of visualizations that we've built for demonstrations that show product capabilities. So if I go in, and the first thing we'll take a look at here is going into the visualization piece so we can see what the end results are. Video is supposed to play, maybe not. Play. All right, so there's my data services, and that's where I'd manage all the data that comes in, and then the visualization services. So when I launch into the visualization services, I've already selected that folder that all of my applications are part of. So I'm now launching into the site that's going to give me access to all of the different visualizations and experiences that are available within Connect. So it fires into Connect, gives me this interface here, and I'm just going to pause it for a second here as well. So a lot of this data that's there is considered streamed data. It's being streamed in from a control system, from an IO server. It's being streamed in from an REST API or some other application. So here I can see my streams, and then my streams can actually be assembled into assets. So when you use the Aviva products, that's done automatically. So when you build a vessel in a SCADA system and it has temperatures, pressures, and all these different attributes around it, it organizes those streams into assets. So in this case, I can see that I have 453 assets with 7,627 streams of data points that are part of those assets. And then I can see all the different visualizations I have. So a visualization can be created as just a simple, basically a simple tile that gives me information from multiple different data sources or multiple different streams, or I can assemble them all into what we would call an experience. So if I go ahead and let this play again, I can see that I've got these visualizations and then I have experiences. So as I navigate a little bit more into this website, I'm going to go over to the browse menu. And if I go over and select the browse, I can see I could browse directly to assets. I could browse to experiences. I could browse to the individual streams if I just want to see data. But if I come over here and I browse into my experiences, and I'm just going to pause this again for a second. I browse into my experiences. You'll see these are all demos that we have, and we have these running in the different locations, Aviva locations located around the world. And you can see the 1S, 2S, 3S things there, because we've actually built a lot of these for multiple screens. So all the context of this stays together with your browser, even if you're spreading it across multiple screens. So if you go to our London office, we've got this big, huge video wall, and you can run one of these experiences that shows the entire supply chain across the 8 monitors that make up that experience center. So you can see most of the ones I have here are just the single screen. But I'm going to go ahead and continue to play the video. And I selected, I think, renewables. I think I selected the power single screen because we only have a single screen here. And it's going to set up this application for me. It's going to pull in all the information that's needed. It's going to start to take the data streams and build the visualizations that have been put together in this application. So the first time you do it, it takes a little bit longer the first time because it does some downloads. Everything that's happening here is simply a browser. So there's no software installed whatsoever. It doesn't matter whether you use Chrome, whether you use Edge, Firefox, Safari. It's just a standard HTML5 browser which renders the application. So there's nothing required special to get this to work. There's no software installed. It doesn't matter what kind of device you use. So it'll work on your phone, it'll work on your laptop, it'll work on your tablet. It doesn't matter. With the way the experiences can be put together, they can be put together to be responsive. So if you want somebody to see data on a phone and not have to scroll around with what I call a keyhole effect, where you got to zoom and pinch and move all around on the phone, then it could be responsive and just show the data visualizations that allow somebody to scroll up and down through them, just like any kind of a mobile website would. So when we look at this experience was put together. I'm going to throw out one of those terms I mentioned earlier when I said OMI. This is actually pretty much OMI. So it's Operations Management Interface. It's just published to the cloud. So instead of getting its data from a control system, all of its data just comes from the streams that are being pushed in from wherever locations they're coming from. So I can build a completely comprehensive interface here that shows my entire value chain, all of my operations, everything in this one system. So one of the things that's important here is because of the fact that we take our HMI SCADA data information and push it up here, that's fairly easy. But if you look at this application, you can see across the bottom there, I've got a map, I've got health and safety information, I've got revenue information, I've got forecasting information. So we're not just taking data that's being pushed up for temperatures and pressures. We're taking event data from health and safety systems. We're taking event data from alarm systems. We're taking that process data as well, but we're bringing that all together into this one visualization. So as you can see, I've also got multiple ways to navigate this. So I can see here, I've got my entire operations visualization of everything. Across the bottom, I have a menu, but that menu is automatically generated based on the model that I've created. So I've got another way of navigating here. I can see the tree view that allows me to drill into the different things. So if I wanted to go, select a particular site or navigate maybe using, let's say, the map. So we have map geoscada systems built in here as well. So they're already pre-built in there. I basically just drop it in and then I can drop information on that. So it's one of the ones I used here. You can see if I move around, hover over these different sites. So if I'm in a large organization, geographically distributed, I can see what's going on in all these individual locations from this one view. So here I can see I've drilled into my individual sites. I can see this an alert. I'm not controlling this system from here. I'm just monitoring and looking at, oh, well, there's a problem, at this location. So I can drill in and look at it. And, oh, I can see that there's an excessive vibration problem. Now, hopefully somebody at that site is taking care of that because they've got that information. But at least from an overall standpoint, I've got a view on everything that's going on. So now I can see before somebody tells me, hey, there's a serious problem and we're never going to hit our production goals, I can see that. I have all that information pulled together for me right in this one central location. So hopefully that gives you an idea from a runtime standpoint or from a usability standpoint, what you can see, what you can visualize with Connect. And again, the data that's being pushed up there is coming from just about any source. And those sources are then being contextualized, so I can start to contextualize when I look at a different piece of equipment. Here's all the information about that particular piece of equipment. Playing that video again on me. So the time to value here is very quick, because if you've got the information existing somewhere, you can use our agents and the sources to publish that information to it. And then you can just I'm not going to get into the development, but dropping on one of those visual experiences and then just connecting it to the sources that are already there is something that can be done in a matter of minutes. So if you're taking this data and publishing it from an agent up to the cloud, you can literally start to build visualizations in minutes and make those available. So then you've got that one platform that everybody can go to and see what's going on. So faster decisions. I can make decisions based on, hey, something's not going on in that plant. Call somebody at the other plant, say, move some production over to this from one plant to another. So we kind of focused on some use cases that our customers have. We didn't create this in a vacuum. We focused on some of these use cases that our customers have. Well, the first one all the way on the left there is data aggregation and contextualization. Honestly, that's the easiest one for us because we've got all the visualization stuff built and we've got the data built. So that's just a matter of pushing the data up there and allowing somebody to build the visualizations around that particular data. The other one was the ecosystem data sharing. That's the ability for you to go in there and say, okay, there are certain pieces of data that I want to share with this other organization. So they have their Connect account in the other organization. They're using their authentication methods, whether they're federated with Microsoft or Azure or however they're federating those or authenticating. And they can only see the data that you share with them. And again, it's only the data. There's no control in here. It's just the data. Remote operations monitoring, being able to look at all the different plants, all the different locations. One of the things that we built in early on was kind of an automatic anomaly detection. So when you start sending data to the cloud, if you're collecting data and putting it in a historian and a database, unless you're actually writing something to report on that and to visualize it, it's just data in a database. We're sending it up to the cloud, and we can have an agent that sits there and looks at that data. So the agent is sitting there looking at that data, and it may say, hey, this is weird. This data point has never flatlined before. So it detects that, and it posts a news feed to say, hey, this tag is flatlined, or this value is way above what it normally is. So that's all built in, that you're getting that automatically. So that's that anomaly detection. Again, enterprise data visualization, so being able to see all of the different facilities, location, all brought into a central location. And then building that digital twin. We've been hearing digital twin for years, right? So the digital twin, basically, since we've got all the data, especially from an Aviva standpoint, where we have the 3D data, we have the 2D data, we have the engineering data, we have all of that information, we can easily build that digital twin. Also track and trace. So our MES products work with the Connect platform as well. So I can do all my MES reporting when I push that data up there. We have add-ins to allow you to do things like, looking at energy to optimize energy and how you're using your, the energy. So we've got other add-ins on top of all of this once you start sending data up to the platform. So Connect Visualization Services, again, relate this disparate data and different data from different sources, being able to bring all of that data together into a central location, being able to distribute it, being able to make it available to many different people in order to see it. Also, once I do that, you can see another example here of looking at this contextualization of data and the way this is put together. You can see that this isn't really an experience like the previous video I had. This is just visualizations put together. So as you see this, if I looked at this with a different device, with a phone or a tablet in this case, you can see that it adheres to the footprint of those devices. So I can then start to contextualize things. So these are very easy to put together. Literally, this is a matter of minutes to put this together once that data is being pushed up to the cloud. And here you can see this is another full visualization. Same type of setup across the bottom where I have access to all of the different resources that are made available. I've got the map information here. I've got the different sites and just the main pieces of information that I need for that particular site. So here you can see this is an example that's bringing, this example is bringing all of this information together in a single location. So I'm looking at generator 02. When I'm looking at generator 02, I've got all of its descriptive information. I've got all of its engineering attributes that are associated with it. I have a status board of all of the data that's being pushed up in real time from that piece of equipment from generator 2. If I let the video play again, it'll scroll and we'll see it a little better. But I've got the 3D model of where this particular piece of equipment is. I've got its relationship with other assets. I've got the 2D information or other documents associated, all in a single place. So this is great for a user to be able to go look at one central location to go look at all this data. But also, what if I can start to use agents to look at this data in this central location and pull it all together for me? And that's where the AI comes into play. I'm going to continue with this video, finish here. As you can see, I just was scrolling around. You can see my 3D information, any kind of documents that I might have, and again, just changing my view. And now I've got my industrial AI assistant. So my industrial AI assistant, I can go start to ask questions. So in this case, I forget what the question was I asked. How is turbine 1 operating yesterday? So this industrial AI assistant has the ability to go look at all of that data that's there and use AI in order to give you results. So it can actually give results based on the contextualization and the data that's available for that particular asset. It can build content automatically. So instead of having to go and create the visualizations you want to see, the industrial AI assistant can actually build those graphics and displays. I've actually got a different example in the next video. I actually thought I paused this video out of there. But so just to kind of go back and look at the whole picture, Connect visualization brings any data that you're sending up to the Connect environment together in one location and contextualized. So here you can see, very similar to the examples we just saw in the videos, I've got HR data, financial data, event data from alarms or other event systems, asset statuses, production data, GIS data, user entered data, all of these things brought in and contextualized based on the asset. Excuse me. So when I switch between different assets, all this stuff is built in. So it automatically goes out and says, oh, yep, I found some 3D. Yep, I found some documentations. I found some alarm information. And it builds these experiences for you automatically. So a little bit more on the industrial AI assistant. So let's take a deeper look at the AI assistant. So this is kind of where we'll see it will actually build some content for me. So here I've come in, I'm logged in, and I'm going to fire up my industrial AI assistant, and I'm going to ask it and you'll also notice that it fixes spelling problems and typos. So I'm going to ask it about this wind turbine, G07, and why wasn't the production as good yesterday as it was the day before or some other previous time or whatever it might be. And you can see here it's actually built the content for me. So these screens didn't exist. It went out and said, oh, you want the information about GE07? I can find all that information and create these visualization graphics for you automatically. So if I added a new generator, I wouldn't have to create any new visualizations. It's automatically in here. So it looks like there was a high temperature event. Can you find me all of the bearing information? So now, instead of me having to go find the trends, look for the information, it's going to go out and say, yep, here it all is. It wrote it all back in the AI assistant. If I want to ask it to trend it, or I want to create some other graphical display around it, I can simply ask it to do that. I can ask it to take all the information that it's created, that it's assembled together. Here you can see it created that graphic for me. And I can ask it to take all the information that it just did and build me a report, put the whole thing in a PDF. And now I have a PDF of this whole thing. So here, something caused those bearing temperatures to go high at the same time. Can you find me any information on the maintenance manual? Because now it can go look into the documentation that's around the context of GE07. So now it's found the maintenance manual for me and presented all this information. Well, I'm not going to read this 171 pages. I'm going to ask my AI assistant to drill into these 171 pages and find me the information on any information that might cause the high bearing temperature to happen. It's going to drill into the document and put all this together for me. So it found the information in the document, kind of created a summary of everything that I've been looking at so far and put it all together here in the assistant. And now if I wanted to take some other action on this, I could ask it to, show me the 3D model, because I've got to send somebody out to that location to go modify or replace the bearings or monitor whatever it might be. Excuse me. So it's going to go out and now find the 3D information about that particular piece of equipment. And now I can pan and zoom around, find out, okay, yeah, here's this piece of equipment. Somebody should be able to get in there and go ahead and replace those bearings or do whatever maintenance needs to be done on this particular piece of equipment. So the industrial AI assistant has pulled all this together for me, but now I want to have somebody else go take more action. So I can ask it for, hey, take all this information that you just did, put it all together in a PDF document so I could send it off to maintenance. And you know what? Convert it to Danish, because that happens to be one of the wind turbines that's controlled by the Danish. So translate it to Danish for me before I send this information out. So there's one location for all of this information that comes in to connect. Now this industrial AI assistant has the ability to go in and look at all that information. So that's a little bit more on the industrial AI assistant. So as far as publishing the data, industrial data comes in a lot of different forms. So the industrial data comes in a lot of different forms. So we can see any kind of remote assets, any kind of Aviva data sources, and then any kind of third party. Because just about any, when you look at what we have available for our data collection as far as standards and other proprietary PLC manufacturers, we've got an agent that can publish that data. So we can take it in from all those different sources. We can bring it all in, contextualize it, and then be able to share that. So the data sources, the data services is really the core of what Connect is. I started with the visualization because the visualization is really what the end user wants to see and the result that you're going to get out of Connect. But the data services and the data storage is really the core of Connect. Because if I wasn't storing all of that information there, I wouldn't be able to do any of the things that we just saw our AI assistant doing. I'm not gonna play through this whole video because this one's a little bit long, but just to give you an idea, now I've logged into Connect Data Services and I can see I've got all my data management. I've got my different agents. This happens to be a Pi agent. I have all of my other data collection nodes. So here I can take a look at, this is my operations database coming from Pi information. It's being pushed from an on-premise Pi application. I've got edge data stores. So I can actually manage these devices that run out at the edge in a container. And I can manage them all from here and have them pull their services down from the cloud to configure these data stores. So I've got these small little Linux devices that can live out at the edge, and I can control all of the data that's being sent up from these devices through my Connect Data Services. So you can see an example of a Linux gateway that's being used to push data. Again, this could be coming from any of those standard protocols, a Modbus or Rockwell or whatever the protocol happens to be. And within data services, I can visualize the data as well. None of this had to have been built. Most of the visualizations that I showed you earlier, somebody actually assembled them. Here, this is just a standard visualization. This data is being pushed up from an edge data store. I just wanted to view it in a trend. I can go ahead and select the trend and view that information. Same thing here. And you can see from a speed standpoint, if I'm looking at this data, it's coming up pretty quick. And this could be lots of data, right? So let's look at years worth of data. So I'll go back to a decade or so versus more than that. 1970 is where it starts. Most people don't have that much data to send up there. But if you do, we can visualize that in data services. So just an example of how the data services is configured. Data gets sent up from the edge store. If you're using the Aviva Historian, that's simply a checkbox. You check the box and the data then comes from the Aviva Historian and goes to the cloud. Nothing else has to be done. Of course, you have to authenticate. You have to have permission in order to do that, but you don't really have to do anything else. Let's talk a little bit about the advanced analytics. So once I send data up, I've got the information there that I can then take actions on, right? So if we take a look at some examples, first of all, since this is a Foxborough user group meeting, talk a little bit about Foxborough. You've got a plant, most likely running a Foxborough DCS. How many of you guys have that? Figure I get more hands than how many people are using the cloud for that answer. So you've got this Foxborough DCS system, and when you look at that system, it does have those Aviva components that are part of it. One of those components is the Aviva Historian. And the Aviva Historian is one of the main sources to send data to Connect. So there's the data source of the Historian, and then there's an agent that just runs on the Historian and just takes anything that you want to send to Connect and pushes it up to Connect. So again, that's that checkbox. That's all you have to do is check that one little box, and you've sent all that data to the Historian. AI-enabled applications. So part of Connect is, as I said, with that community data sharing, those communities can also create applications that run on the Connect platform. So if they want to do predictive quality or predictive throughput, or some other applications that a third party has put together, you can do that at the Connect, within the Connect platform. So just to look at a couple of use cases, aggregated data reporting. And again, the couple of customers that I mentioned earlier, I look at how they utilize these applications and what they're doing with those applications. So you can see some of the results. All the data gets stored, contextualized to the industrial information. They have the ability to go view performance information about the entire plant without having to go out to the individual SCADA nodes, HMI nodes to be able to see that. And they can use Connect to drill through the individual events and other pieces of equipment that may be affected by those events. Predictive set point optimization. This one is really pretty interesting in a lot of the large process industries. Two specific customers that we've worked with recently in what we call the Lighthouse Project, they identified that, yeah, the operators are pretty good at running the process, but they could use a little help running that process. So to have the ability to aggregate all the data from the control system and then have some algorithms that are running in the Connect environment, determining how you could better control that process. So predict based on a set point in the past or the current operating conditions as to what's actually best for the process. So the latest one I was involved with basically was sending a lot of data up to Connect. They had an algorithm running in Connect in the advanced analytics module that was determining that if the set point was set to this value, the process would run better. Well, one of the first things I said earlier today is Connect is basically outbound only. So Connect is not reaching back into the system and saying, here's a new set point and setting that set point. It's simply outbound. It's doing all of its calculations, all of its work in the cloud, and cannot write back to the control system. So this particular use case, basically, their application reaches back up to Connect to grab that value and display it to the operator. They don't do anything automated. They just go up and say, okay, what's the best set point that the system has calculated that it should be set for? And then it reads it, displays it to the operator. The operator, the last case, the operator had to re-enter it in. I think they've since changed it to a button that just basically, yep, accept the set point. So they're not doing it automatically. The operator still has full control, but the system is calculating what that set point, what that optimal operating condition should be. Enterprise visualization. This was basically the first use case for Connect. We have something called the UOC, basically a Unified Operations Center is what UOC stands for. And that was kind of an on-premise application that you would install system platform, OMI, all those different components, and you would run it on-premise. So Connect now has that capability, so you don't have to invest in putting all the services and all of the infrastructure together in order to do that. You basically just send everything to Connect and leverage that environment to do this enterprise visualization, all in the one common place. So data sharing, an OEM that built irrigation systems. So they build irrigation systems. They're operated by the end users, a lot of cases farmers using an irrigation system. But they wanted access to all of the data from all these different irrigation systems located all around the world. So as part of their application, the irrigation system was actually sending the data up to Connect. So when it was up in Connect, the end user had access to the information. So the end user could actually see within Connect and have visualizations and be able to take a look at how the irrigation systems were working. But at the same time, the OEM who built it had access to all of the customers' information to help optimize how those operations were running, how the irrigation systems were running. At the same time, they had other vendors or other entities that needed to get that information, so they could actually share it with the other suppliers that were building other pieces of equipment that were part of those systems. So basically a shared community, all only accessing and securely accessing only the data that they needed when they needed. Self-serve, they could just go find the data. They didn't have to wait for a report that the end user was going to write a report and send it to the OEM, and the OEM was going to share it with the other OEMs. They could go get it anytime they want. Predictive downtimes within an MES system. So a system basically for a manufacturing operation that, based on what was being produced and the product that was being produced, could determine that when that system was going to go down based on that information that was all put together. So they could proactively manage the production for the different pieces of equipment. Predictive throughput, same thing, using the MES system, collecting all that data into the MES system, bringing it up into Connect and being able to analyze it. They're able to look at it and go, oh, hey, we can't even take all these orders because we cannot produce it based on how we've historically produced in the past, because all that information is being sent up to Connect in order to pull it all together. So predictive throughput. That was pretty much what I wanted to go through. I can open up the floor for any questions. We could dive into how to build all this stuff, but I don't think anybody wants to get in and start building Connect visualizations right now. So, any questions?
How much, I guess, pre-work do y'all typically see companies have to do to get their data in a spot where you can even use, like ours, to say there's no context to most of what we generate is an understatement. And so, like, how much, time do y'all see people have to do on the front end to even be able to use what looks like really neat tools?
Yeah.
There's no way the software can tell what this is, because I don't know what it is.
That's a really good question. And at the moment, most of the data that gets sent from our system is contextualized. If it's not contextualized, you could build the context, basically the asset framework within the Connect environment. It's certainly a timely process, and it's not a tool that we currently have, but it's definitely on the books to have an AI tool that adds the context to that data. So it can kind of go look at, okay, based on some kind of naming convention, let's assemble all of these different data points into this particular asset. But it could be a timely process depending on how much information you have, but it can also just search anything. So if you're just interested in bearing temperatures or something that has that context in the name, it can automatically find it. Any other questions?
The return on this? What is the, I understand the value, but the example is almost, the AI found the problem that I was unaware of, and then it prescribed a solution, and it told the guy to go fix it, and it's like, okay, I get that could happen, but are they using it to that extent? I mean,
Yeah. That's
ideal, or is that like, this is where we can get to something?
no, I mean, if you go look at some of the use cases that are published, it's in the millions of dollars that people have saved based on the predictive set. The set point application was for a powder that was being sold, and just making sure that that powder was the right amount going into each container was millions of dollars a year in savings. So, and that was just with some algorithms that looked at a lot of parameters across the production filling lines and sent the new information down to the operator. It was literally in the millions. And you can, if you go to the Connect website, you can see some of the stories. I didn't want to kind of go through all the stories here, but
And the time frame, if you were to buy one of these, you're looking at 6 months worth of prep work, and then put the stuff into the neck.
no, I think that
Realistically, what's a ballpark number you're talking?
as far as speak on the licensing costs, because that's basically comes from the sales channel, but from a time standpoint, you're basically, you know, you can get data up and running from a system in minutes, being sent to the cloud and put visualizations together in minutes. So from a time standpoint, very quick time to value. The licensing is done based on that magical number that you saw at the beginning that was a number of streams. So it's a number of streams of data. We actually don't charge you to store any data, which is it's kind of nice because you can put as much data as you want there. We only charge you when you get value out of it by taking the streams out.
Like, okay, how long does it get something up and running? You kind of referenced it earlier with the Lighthouse program, but could you expand on that a little bit and kind of what that could look like if anybody in the room is interested in exploring the use case?
Yeah. So the Lighthouse projects are projects that we do for customers who are interested in using our technology. I don't want to say they're free, but they're free as far as our time. So we provide some assets and assistance, but we don't build the application. We help specify how the application is built and what should be done. So our Lighthouse team kind of follows that process all the way through, helps to write the specifications for, you know, what is going to be done, what the end result is supposed to be, and follows through that process. Most Lighthouse projects don't last more than 3-4 months. So from a time standpoint, they're usually pretty quick. They're usually pretty big hits, like the powder example. That project took less than 2 months. And, you know, they were getting the return on that in less than 2 months. They were getting that return on the savings that they had.
Case studies, process yield improvements, or efficiencies, real world with Foxborough DCS.
We definitely have stories on the process systems as far as with Foxborough DCS. I don't specifically know that any are pointing to Foxborough DCS, but a lot of times we might not even know that because the data is just coming from an OPC UA source or some other source being pushed into the system. What's that?
The link to your case studies.
Connect.aviva.com.
You're working on an AI tool to provide context for information that is contextualized. I was a little curious, like, kind of how far along that is. Also, I've got a lot of customers who their tag names aren't, don't have unit references in it. Their tag name is based on, well, this is the 38,212 transmitter I'm adding to my plant, and so it's TT38.
Yeah.
So do you have any way of ingesting PIDs to provide context?
Schneider does, I believe. So Schneider has a tool that actually takes our engineering tools, the P&IDs, and builds the system based on that. That exists today from Schneider. As far as from Aviva, I don't really know time frame, what we have for that contextualization and in the roadmap. But those tools do exist from Schneider today. It's part of it. somebody from Schneider could help me. EcoStructure, automation. Yep.
Was this developed through the SEUG arm of Schneider somehow, or at Inwood?
Our cloud program was kind of based from the Wonderware folks in the beginning, but yeah, I'm sure that there's a lot of smart people that were involved. I'm not positive on that. I wouldn't say it's a replacement. It's certainly, additional functionality. It's more widespread functionality because it is available to just about anybody, the Connect platform, without having to have Connoisseur and the SimSci products. So I wouldn't say it would be a replacement for it. I would say it would basically augment it. Anything else? All right, well, I'll be around if you come up with anything else and you want to pass it by me. Be around most of the morning, so, and we got a little bit of extra time left. All right.
Give you some time back to have a break before our next presentation. Just at a high level, we've talked a little bit about this and I think we've already answered a lot of the questions I was planning on putting out to you guys, but we've had a couple situations where we weren't sure. We've kind of heard concurrent drivers on the FTC 280 as a general concept. So really this is, I'll draw attention to some limitations we know of and ask you guys if you've had, your sales rep or you tried to do something that didn't work. And I was going to talk about two, but Thad cleared up exactly what those two had in common. The Ethernet IP implicit driver we saw is not concurrent with other drivers. We've been told the Modbus server driver was not concurrent. And essentially the reason for those two is because those are both custom drivers at this time. So I think across the board, we can say that if you've got a quote unquote custom driver, that it's not going to be concurrent with any other drivers. So the ones that should be concurrent right now, Thad, stop me if I'm lying, would be OPC. Well, do you just want to say, or do you want me to give you some time to look it up?
want to do it, we're happy to discuss them. But, as you said, that's pretty much that, see that's what we want. So keep it at ID, doing client, Modbus, TCP, and also TSA. Profinet, that would be concurrent, but just,
All right. I'll just repeat that today the concurrent drivers are OPC UA client.
Hello.
Oh,
See, Marcel fixes everything, right? Go ahead. You keep going. Sorry.
OPC UA client, Modbus TCP client. Is TSAA today or in the future?
Oh yeah. TSAA,
And TSAA client. I can
and
guess
then
there's a server.
later this year, Ethernet IP.
And later this year, Ethernet IP implicit will be, or 2.0 as the manual calls it, Ethernet IP 2.0 will be concurrent in the future. And you said Profinet is by
Yeah.
its nature not compatible and will never be concurrent.
And Modbus server is the custom, and I don't see us rolling that into a concurrent configuration.
Gotcha. All right. Has anybody else tried to do concurrent? Is anybody running 2 drivers on their FTC 280 today in production somewhere? Yeah, we've done some limited testing in our lab, but we haven't seen it out in the wild yet. All right. Very brief. Anybody else have something about concurrent drivers on the FTC 280, or should we all go get coffee?
How about future drivers on FTC 280?
What are you asking? What drivers we want to see?
Yeah.
Speak up, guys. What do you want to see?
TCIP, Internet IP.
Yeah, I think OPCUA, Modbus, and Ethernet IP covers this crowd pretty well, and TSAA for the Tricom.
What about online upgrade? Is there a need? Does anyone that's using FTC 280 see a need for online upgrade? No. Yeah.
I check. I think Scott's right on that. Because as you start adding more concurrent drivers, right, you got more and more stuff hanging off of this thing, and like currently, if we have an FDSI and we have it going out and it's talking to 1 or 2 devices, well, the PLC's down. Well, that's a good time to do whatever to it. But as we get multiple things happening at the same time, it's going to get harder and harder to shut this off. Or you're going to have to buy one for each segment, which is not a terrible idea. I'm not trying to sell FTCs, but philosophically, right, one of the things in a distributed control system is the D is distributed. And we've kind of, over time, everybody's collapsed them all. As you get a controller that can do more and more, you keep putting more and more and more stuff into that controller because it's cost effective. But sometimes it's cost effective, but then you really limit what you can shut off, and you have, we can't take that area of the plant down because we've rolled it into this area, and we kept putting more and more into it. And this, what you've done with the concurrent drivers is you've let us, which is good, it's cost effective, roll more stuff into the FTC 280, and that's wonderful. But there is a time and place when you're architecting this, you need to be thinking about, do I really want to? Just because you can do something doesn't mean you should do something. So you got to think about that.
All right. Next presentation or break?
I think break. We're 7 minutes. I mean, we can add 7 to the break and come back on time and go from there.
All right. So what time is it now? Because this clock is wrong.
It's 9:23.
9:23. Be back at 9:30 for Bob's presentation. Nope. what time? 9:35, something like that.
Yeah.
For Bob's presentation. Is Bob in here?
There's Bob.
There he is. He's behind the column. I couldn't see him.
Yeah. Can't see.
All right, Bob's up next at 9:35.
Yeah, that'll work. That's 11 minutes.
I don't know if I'm waiting for anybody else to come in here or not, but how many people in the room have FCP 270s? Is there any plans to get those FCP 270s over to FCP 280s? Okay, so I'm hoping this helps somebody here. We recently did this. I'm not saying it's difficult, but we went through it, and I want to show you some of the steps that we did and sort of what we looked at and how we got to what we did. Start off with introductions. My name is Bob Jones. I work at Galloway Company. I'm here with Matt Crowley is out in the crowd, and so Matt and I basically did this together. And Sadia from Galloway is here as well. If you haven't met Sadia yet, you should go talk to Sadia. She likes meeting new people. Our Galloway slogan is we delight our customers so that they can delight theirs. We make products that we don't necessarily sell. We sell to our customers so that they can go in turn and sell those products. So we make ice cream mix for two really big chains that you're probably familiar with. Other people that buy ice cream mix from us are around the Wisconsin area and in the Midwest. And we make sweetened condensed milk for the candy and the pie industry. And we also make creamy liqueurs like think rum chata. We mix the cream and the rum together, and we give it off to them. They flavor it, they bottle it, they sell it. You won't see our name anywhere. So our motivation for this is just to maintain stability and consistent production and have healthy controllers. I don't know if you ever looked at this chart before, but there's a pretty significant difference in performance between FCP 270s and FCP 280s. And basically you get a lot faster processor, a lot more memory that you can shove programs and blocks onto. You get faster field bus support and faster network. So for us, that means we get to write bigger programs, we get to run fast and run long, we got a longer life cycle for the FCP 280. We have improved firmware stability. We just like being on having all of our controllers on the same level of firmware. We're using 93011. So just FCP 280 is just a newer, better, faster, stronger, better at peer-to-peer communications, easier diagnostics for troubleshooting. Amen to that. Oh shoot! I forgot. I was gonna bring that for you, and I forgot it in my luggage. I was gonna put it in my luggage, and I totally forgot. Yeah, you're absolutely right. That's handy too. I like the FDC 280 just because it's like we want to work on what's modern, what's relevant. It's just better. Our goal when we did this was a successful startup and have full operator confidence. Basically, you shut down the plant, you have a down day, you want to be able to kind of come offline, swap that controller out, come back online. Really, to the operator and to operations, it shouldn't make any difference, and that should be your goal. What we started with was a couple of years ago, we had a problem with the historian, and we pinned it down on a controller. It's hard to say what exactly it was. It looked like something that was a communications issue deep in the controller. We narrowed it down to one controller, and we kind of had to jump through some hoops. We were in the middle of a larger project. We didn't have control of our system definition. Schneider Electric did at that time, and it took a little bit of extra effort to, while in the middle of a big project, have the sysdef changed and get it to we could do that. But since that was kind of well documented, we started with that document, and we started with this Foxborough documentation, that KA document there. The Foxborough document, not to knock it, but it's 2 pages long. It's 18 numbered steps. They're really high level steps. They're basic instructions. They're not details to follow. And then in addition, we had some emails and tips and suggestions from both Schneider Electric and David Johnson. And we kind of threw that all into a little blender, and we made an outline, and we started from scratch. And we came up with a very detailed document. The document I'll show you here in a bit, but let's get through the slides, is about 10 pages long. Not that it takes 10 pages to do this. Some of you, Joe can probably do this in his sleep. But, you know, we just wanted every detail documented, and I think like an astronaut, you know, it's like you're an astronaut, you can go on a mission, but you might not know how to fix that satellite or, you know, do whatever. So this is your training leading up to that. So we just documented everything as well as we could. We had that document. We rehearsed it. We did dry runs. We did timing of uploads and shrinks and save alls. We went and grabbed did all of our textual edits that we needed to practice. But that was just for rehearsing and seeing how well our document matched. And basically what we ended up with is faster field bus scan times, faster block execution, total control cycle was greatly reduced, OM scan was greatly reduced, and the station idle time was, if you look at those numbers, it's really kind of inverted. So it went from, this was our most loaded controller, by the way, so it needed it. It needed this. We did 2 controllers at the same time, and the other one that we did, the aftershot is not as impressive as this one. This one was fully loaded. But yeah, that's about it. I'm going to show you a couple of things here. This is the document that I was referring to in the slides there. And like I said, this is 10 pages long. And there's quite a bit of detail here. Sorry, I should have brought my mouse with me so I could scroll. So the good part is, I think down here, a lot of this is prep and stuff to watch out for. We don't even get to the decommissioning, like the actual down day, until like page 6 here. So we go through all the steps. And, you know, just to show you, I'm not going to go through every step here. This is just meant to be helpful for you guys. Hopefully it is for somebody. But just, you know, just to write all this stuff out and have something that you can follow step by step. We actually had this in a 3-ring binder, a playbook, and it was very handy to kind of carry that around. And we had the playbook even broken down into sections. So this was one section of the work that we were doing that day. It's like having everything written out and just kind of having you know, a Bible for the day that you can kind of take with you and follow through all the steps that you've practiced. Let's see. Then the next page is the 280 startup. Yeah, everything went really well, and I just want this to be encouragement for thoroughness in documentation, and just if anybody has any questions how we did this or how it went, feel free to ask. Any questions? Absolutely. Yeah, two pages and 18 steps versus, you know, this, which is fully detailed, right? This is really good. I thought about, in fact, I think the reason I'm up here speaking is because I offered to David at one point in time after this project. I said, hey, we should turn this into a white paper. If I kind of whitewash this a little bit or clean up, you know, some of the naming, whatever, I could turn this into a white paper. So I think that would be really handy. Is there anybody that would benefit from that?
It's nice to have a check sheet that really somebody's thought about. Now they may, we, you, and us, and some of the review on this, may have still missed something that somebody else is going to stumble across, right? Because they may have something slightly different or whatever. But we definitely got it covered better than it was prior to this.
Yeah.
Right?
Yep.
And now if we made that available, perhaps other people could use it and mark it up, and then we could get it even better done.
Yep, definitely. We don't have any 270s left, but certainly I see the value of this document now that we've gone through this. So I like it. I'm actually kind of proud of it. You know, like we did a lot of work leading up to this. We didn't, like I said, we started with those 3 documents in the beginning, kind of think about like just tossed them into a blender, threw it back at EOSIS and said, hey, would you guide us through this process? And basically we got this document here that we honed in on over the course of, say, a 2 or 3 month period. And by the time we executed, it went fantastic.
Got another question? Did you start out with fiber field bus, or did you add it as part of the project?
Who's asking that? Where are you? Oh, okay. Say it again.
Did you start out with fiber field bus, or did you add it as part of the project?
I don't think we had to touch anything with that. Yeah. Right. So, that was the other part of it. I kind of over it in the slide presentation. You're right. With the way that the 270s channel out and the way the 280s do, there was you got those little adapters. I forget what they're called. Yes, that's what you're asking. So basically what I did leading up to it was I went out to the cabinets where we were doing these controller swaps and just made sure that every single cable in those cabinets was, cleaned up. It was well labeled, so I knew what it was. When we shut down the 270s and pulled them out and put those 280s in there, everything was ready to go. Like I don't even think we even had like an A and B flip-flopped. I mean, like everything was, it went right the first time. Any other questions? Here's one thing to consider. There was an additional document that I chose not to list in the slide presentation. There was one on how to keep your MAC address. And when I don't know if I told you this, David, but when I told Paul Dobbin what we were doing, he says, well, you don't have to keep the MAC address if you don't want to. You can let that go ahead and auto-populate. So there's two versions of going through this. You can, if you felt the need to, you can modify your MAC address of your new controller at your old controller. I don't know what you get out of it. I know there's a document for it. I don't see it as necessary, and we actually did it in the way that ours changed as we added the 280. I think for us, and I don't know how well I can explain this, for us, the reason it was critical when we did the February 2024 controller swap was because we had a sysdef that was then in the control of Schneider Electric. Again, this was for a bigger project and add new servers, other new controllers. It was for an expansion in the plant. And so when we swapped out that controller, with them already having a copy of what we had on site, they were already making those changes. So those changes offsite needed to match the MAC address of the one that we were doing. That controller swap, we had to. You have to decide whether or not that's important to you. You got to consider what David's, mentioning there. No. I like that question. This is what motivated us to go to this level of detail. This is the Schneider Electric document, replacing 270 with a 280, where the letter bug is the same. And like I said, this is okay. These are high-level steps, but these aren't detailed. This is 2 pages, 18 steps, I'm not knocking this, but there's a stark difference between this and what I presented. Yeah, we made ours very specific, but like what David's suggesting, if you turn this into a white paper, there'll be some level of that detail that's going to come out of there, right? But still, you can rewrite it. Like if we get that down to a skinny white paper, you could take your controller names and say, these are my controller names, these are my program paths or my file paths, feed that into AI, dump that document in there and get out exactly what we got and, have it, with your details. So, I mean, it's I don't want to make light of it. Like I'm not going to say it's easy to do, but it's not something that we do every day. So we took it serious. My opinion is it should be a Schneider document.
On here, step two, this is the sequence you go in order. Still saying, oh, jump to page 92, look at this step. Now I go here to this step. We've all done these multiple times and rewrote the document so it was back to those college days. We always redid everything and made our own guidelines.
To be fair, Schneider's documentation is good or better than most other people's, most other systems' documentation.
Agreed.
I would not say that it's lack of documentation. It's just that everybody, I used to be, and this is not Schneider, but when they bought FoxRay, I remember installing FoxRay, step one was go to Appendix A.
Yeah.
I'm like, really?
Right.
Because the first step in the procedure to install it is to go to the back of the book, and then it's like, put all these things in, and then go back to the front to step two. I'm like, that's crazy.
And I remember, when we used the little projects back in the day, you had like 10 binders with all the documentation, and now all that is digitalized so long. But I'm just curious,
Yeah.
And then with all the control systems, I hear the documentation, how the documents are lacking, so I appreciate,
They're no worse than anybody else, I will say that. I don't think they're, they're not significantly better, but they're definitely not.
I wouldn't say it's lacking. If those 18 steps are correct, those are good steps there. Yeah. Well, like so the if is if you knew all of those steps by heart, if you've performed some of those steps before, those 18 steps are more than enough for Joe, But, like I said, we don't do that every day, and we just wanted something with a lot more detail.
follow this channel, not really.
Right. Okay, thank you.
This, I'll email you, I just found it,
Okay.
that has after, here's everything you check, check to see if any IND blocks are in manual.
Oh,
And
yeah, stuff
a
like
bunch
that,
of
yeah.
details like that'll burn you if you don't check them like that.
Okay, that would be good, Roger. Thank you.
Check, check. There we go. All right. This is you're gonna like this, but I thought of something that you need to do in an FDC 280. So I finally, because I'm doing a thing, this is the future without the 232, 233s, but now we're gonna get them back. But you still got a couple years, so maybe we care. Go ahead. Well, that's the 233s. What the problem is, and I want to say first off, shout out to our marketing department because like I don't always dress like this for starters. They kind of give us a code thing, but they made these templates and they are very professional and very nice. And they also capitalize everything on like if you put them in the blocks, it doesn't matter what your font is. So it puts so that's a little s 233s, but it put it big. So, but they did a great job putting all this together. So good for that. And I've really been pleased with all that. So good for them. All right. Well, first of all, if we're going to have to get rid of them before we get them back, or if you want to transition them over to an FDC 280, these are some things you're going to need to think about while you're going through it. The good news is, even when we can't get them, they're not going to stop working. They're still going to be there. You can't get them. When I first did this presentation, I said you could get them for a little while, but now you can't. So how long till we can reorder the new ones? Maybe a year, year and a half, 2 years. So we got that. But there's things that, go ahead. Well, I think they're just filling the orders that people had on order. They're right now go ahead.
Could you repeat the question again? I didn't hear the question.
The question is, Roger said he thought that they were available again, but they're not, right? We don't have FBM 232s available. You're just filling orders that were already placed.
February 16th, they were officially out of buy automation.
Yeah. So as of a week and a half ago, you can't get them anymore. So, but here are things you can do to transition over to an FDC 280. So this is what we're going to be able to do. So I'll teach you to do that. So go that way. Huh? All right. So how did we get there? That's my thing. If you don't remember the past, you're doomed to repeat it. So this is some of the UNC stuff coming in again. The COM 10s and the Gateway 15s and the old integrator 30s and 30Bs. Those of you who go back that far, probably not a lot of people in this room, but those were the old serial gateways they had. And so we had this 30B serial connection to a Modbus or Allen Bradley by a KF2 or KFC module. And they had some custom drivers as well. But basically, it was a serial gateway into a remote device. Those were the old integrators that they had. So I used those a lot back in the day. And these were gateways, and they were like a CP, but they only had gateway IO, right? You couldn't attach FBMs to them. You just had a gateway that would go through this device, and they ran a limited block set. Okay, you didn't have any real IO, so that's what it was like. You had to make peer-to-peer connections. So when we got the 100 series, got phased out, and then the integrator 30s got phased out around that time, and then they started with the FDSIs. And they started with the FBM 224, which was a serial Modbus one. And then we got the 230s, which were also serial with serial drivers for Modbus and Allen Bradley SIP protocol. And then they had a fault tolerant version of those. And then we got the FBM 232s, and that was Ethernet. And we had several drivers. We had Modbus, we had Ethernet IP, the Triconics one, the TSAA. And then they had a fault tolerant version. So finally we got an Ethernet gateway that just went on our node bus. It was just on our field bus, and you stuck it out there in an FBM slot, and everything was great. And so they had a few differences though from the old gateways when you got them, right? We had all been used to the old gateways, so we got the new stuff, and it's like, oh, okay. The bidirectional blocks they write, if you put an old integrator in manual and you wrote to an output, and then the device wrote back to it, it would flip that bit for you, and then you were good. Well, on these, it was a little different. If you have a pack in or something that had a pack out writing to it, you had a pack out writing to it, and you set one bit on it, it was notorious for like flipping those bits back. So you had a problem getting it to consistently do that. It wasn't quite the same when it was in manual. Performance was so-so on the Modbus. It's not very great on Ethernet IP on the device drivers that they have in the existing FDSIs. It's not as bad as the serial performance, but it still has a lot of performance issues. And the synchronization to the CP became different when it was running in a integrator 30 and it was a peer-to-peer connection. Everything was very deterministic. You knew what you were going to get, when scans were going to come in, what they were going to do. Once you put this thing out on an FBM, it was running asynchronously from the CP, so those updates were coming in at different times, so it was hard to know what you were going to get. But it also allowed us to do things differently from the old way of doing things when we got the FDSIs. And so now, when you had the old serial gateway blocks, they had to be in the gateway. And the FDSI, because it was out on your field bus chain, you just mixed them in. You could mix your blocks together. You didn't have to make those peer-to-peer connections, and they were all there. So it was easier to configure, and it made for cleaner strategies with fewer input and output flags. If you were putting this into ICC or even the Orchestra, the Evo control editor, keep going, I can name it 100 times. But and it could be physically located way away from the FCP, which is what people did. They had fiber out to a bunch of FBMs far away. They had a PLC out there, and they went over there and they said, oh man, I got my control processor in this rack room over here in the powerhouse, and I've got a BMS system way over there. And they would go over there where the FBMs were, and they'd put this in, and that's how a lot of people did it. So it was good. It was good as far as it was. So they had the underlying platform of this, and they were running, as there was an operating system, it was Windows CE, it was a Windows embedded control thing, and that's what it was. And what was bad about Windows CE? Well, it's a Microsoft product. Let's start with that. You could start and end with that, really, if you just want to make it easy. But so they got CE in there, and Microsoft killed off Windows CE. You can't build devices with this anymore. That's not Schneider's fault. That's just life in the big city, and they did that. So Windows CE reached into support. They quit making and updating in 2013, so that's been a while. And then the extended support ran to 2023, and then Microsoft will let you continue to sell it until 2028, and then you can use them forever. But you know, Microsoft doesn't really care about this market. So now we got the FDC 280 to replace that. We can't make these anymore. Thad's going to make a new one, a B, that replaces it functionally, but you couldn't even if you wanted to make the existing FDSIs, you can't, because Microsoft doesn't let you use that software. It's outdated. There's a bunch of reasons you wouldn't want to, but you couldn't if you wanted to. So now we get the FDC. Well, it's a little more complex. It's a CP and it's an FDSI, and it's a little different. And now you got to figure out what to do with your blocks. And this is where we can make an improvement to the FDC 280. If you could add into our block set some control blocks, it would simplify a lot of the moving things, like a GDEV block, a motor block, a PID block. The control side, you don't have to put I/O out there on it, but it would be really nice if it would support those additional control blocks that already run in a regular CP. Because really all they support is the DCI blocks in these FDC 280s. So let's look at the blocks in the FDSI. This is when you got to move these things, if we're going to do this, because now you can't mix and match your blocks, right? If you have a thing right now, and if we had a bin block and a GDEV block and a bout block, this would be a typical setup for running a control thing. And your IO is coming out of the PLC and you've got it going through the gateway. You can't do this anymore. Now you got to split this in the FDC 280. You've got to move the bin and the bout, and then you can't move the GDEV block because it doesn't support it. So you've got a peer-to-peer coming in and a peer-to-peer coming out to run your block. So that's not ideal. If you have a compound that has a mix of FDSI and FBM related IO, you can't move it directly into an FDC 280 because they don't have a way to support the FBM 201 on it. And then you've got the FBM 232 over on the other side. So you've got to break this up. It's not, the end of the world, but you're going to have to break it one way or the other and put your peer-to-peer connections on. If you have stuff like this, similar type thing, you're reading in an analog in from the field, you're say driving a drive like Ethernet IP, you're sitting there talking, communicating to the PLC with it. You've got your route block driving the speed of the drive. Now you got this PID. Now you got to push that back into the FCP with the analog in, and then you've got your output sitting in the FDC. Man, that's hard. FCP, FDC, but you got to split it such that your output still will talk to the PLC. So you got to push that into the FDC. So then you can make a connection from the FDC 280 to get the route block up, and you can make it work that way. So you got to kind of break things apart to get this to go. Lots of stuff like that. Every time you do this, you're going to be adding peer-to-peer links. Okay. And what you need to keep in mind as you're doing this is you want to be able to, if you have mixed your DCI blocks that are going to it and your other blocks, you want to pull all of those DCI blocks today. You can do this today while you're running to make your life better or easier if you're going to migrate to an FDC. Okay, you're going to do that migration. You want those DCI blocks to be in their own compound. That doesn't create a peer-to-peer link if you're doing it today, but it allows you in the future to pull those blocks out, move them over to the other compound, keep them all together, and now you've got a clean way to make that migration, and it'll work because you don't have to retest it. You've already tested it as you built them and made sure that all you're doing is moving them into a different compound and saying this compound has got my communication through the FDSI, and now when I move it, or you have multiple compounds, but they all need to be just, these compounds are only dealing with my FDSI, and that lets you be able to move those blocks over in a chunk. So, and that's what you need to do. You need to create these logical boundaries around this problem as you're moving them. You need to know where you want them to go. And if you got blocks that you don't know, if you had multiple, and we see this where they've got things across, PIDs and things like that, you can't put them in the FDC, but you might have, what happens is you have blocks already that are split in two FCPs, and now we've added an FDC into that. So now you've got, okay, this has got to go somewhere. I got to pick which side of the peer-to-peer connection I want it on. So usually we try to keep the outputs with the control blocks when you're doing that, and then the input will come in on a peer-to-peer. It just works better generally. So the hardware is where things really got complicated, though. As far as how you're going to do it, because it creates all these weird cabling issues and stuff, and that's why they're going to go back and build us another FDSI so that we don't have these problems. But, so we had a setup, and you need to determine where you're going to put your FDC 280. And most people, I think, would think of an FDC 280 as effectively another controller, and a lot of people put those controllers in a rack room, just like you do your normal stuff, and you put your field IO out wherever it goes. So you got to keep in mind though that you're probably going to need additional cabinet space, power supplies, another connection to your mesh network, because that's got to be part of it to get this thing to work. So, so now we'll work on it. So if you're using an FCP today and you have a little base plate with FDSIs and a local base plate, and they make that, you're good. That's basically an FDC 280. It's the same thing, except for you don't have FDSIs. It's the little, it's like all I did was have a CP, FDSIs. They were in a local base plate. No big deal. You got this beat. That's the easiest of all. If you had something that looked like this, you had FCPs, you had a 232, you connected to the devices, you just replace that with an FDC 280. No problem. Looks like that. Easy. So that's easy. Now, the next part though is if you're using them in there and you got the cabinet space, the mesh and all that, you're good. But now if you have a mixed local base plate, and this is what you wind up with, you got your FCP and you have a 232 devices, and you got a 14 or 201 or anything that's talking to other hardware. Now I got to have an additional base plate to make this work. I can't get it out. I got to split them. And so you're going to wind up with an additional setup. You still got to keep your old IO rack. You got the new base plate for the FDC. It connects to the device, and then you keep working. But now it's taking up more space in your cabinet. This is why people were having so much heartache over having to move to these. It's like, oh my God, I got to have more space in a cabinet. I got to put this thing in. I got to make it all work. And now if you're using them in a remote base plate, now you got even more decisions to go with, right? Now I got this FDC 280. Do I put it in the local rack room and do something to get fiber out there? Or do I put it in the remote one and come back to the space? So you come into something like this. And so now you get these kind of things, right? You've got the FCP and then 2 F2s and fiber and 2 F2s in a device. This is how people were doing it out in today. And that's how you get way out there with your FBM 232s. You got it halfway across the world and it's talking to some PLC over there or whatever. And so now you got to do something like this, where you got to have this something new is like some sort of, you know, switching from cable to cable. Yeah, a converter of some kind to get you where you want to go, to get you out to where you want to be to the device. So you either do something like that, or you wind up with coming out here and you put it out at the field. So now you put your FDC out close where the FBM 232s used to be. It's an option. I mean, you can do that. There's nothing wrong with that. It's just now it's a different configuration. So you got to put it somewhere. So you got to think about where it needs to go. You got to think about cabinet space. You got to think about power supply connections. You got to think about mesh switch availability. All of these things were things that got introduced by trying to do this, right? So you wind up with something that in the old days looked like this, and then now it's going to look like this. So it's more stuff. You still have the old stuff there, and now you got to get a new piece in the puzzle. Set it up this way. You can set up 100 different ways. I mean, it's all kinds of things you can do to do it, but all of this is adding these additional pieces into the system. So these are, but to take the takeaway from this is, if you want to prepare, you want to think about using an FDC 280, and even going forward, I think that there's probably a lot of value because of what they did to us with this, is to think of, if you have blocks that are going to a foreign device, a PLC or whatever, you would be wise, I think, to keep them in an individual compound, you know, multiple compounds. These compounds are talking to this device, so that if in the future, for whatever reason, you need to break that apart, you can do that. And what we did is we got very comfortable with just interspersing those blocks to make it easy, and there was no reason to think we shouldn't. I'm not gonna, you know, it wasn't like a bad practice. It's just like, who knew? So you got very comfortable putting those blocks all together, and now we're having to pull them back apart. So you got to be able to do that. So that's the thought process behind this, and that's what you need to be aware of as you go forward. And that would be my recommendation to you. When you have time, have a project in an area, if you have an FDSI, I think you would be wise to start taking those blocks and pulling them into their own compound and testing as you go. And then you can say, okay, that one's cleaned up and ready to go if we ever need to do it. It doesn't look bad and it works well. And I was going to ask David McCullough, is he in here? Did he walk out? May have gone somewhere. But we had the ECBs that we had for these. You can move the ECB, John, and where did we put the ECBs? You can move those so that it's not as big of a problem, right? If we put them instead of putting them at the top level, if you put them in the compound with the blocks, which is not where you normally would put your ECBs, that also helps clean this up. And then you don't have those ECBs connected to the CP, right? When you put the ECB under the CP, it becomes part of the CP name and everything is part of that. If you put the ECB into the compound with the blocks, which is legal but unusual, then when you move that compound, that ECB goes with it, and you don't have to do any reconfiguration of your blocks if you do that. True. Or you could put the ECB in its own separate compound and then just make sure it moves. But you don't want it under the station block, because by having it under the station block, you've got a problem. So, all right. So what time is it? I'm supposed to go until 10:45. I have 23 minutes and I don't have any more material for that. So, at that point, I would say we take a break and come back with an FPS power supply discussion at 11 o'clock and do a couple quick ones there until we get to lunch, and then we will come back and be on time. So let's take a break from now until 11 o'clock.
Hey,
11 o'clock.
you have one question, David?
You ready? This is going to be a quick one, I hope. And it's what I really need is feedback. And I'm like a lounge singer. Yeah. Anyone from out of town? Tim says hi, by the way. My brother said hi. I texted him hi. He said you're a good dude. What he said. My older brother. He's he turns 60 this year. He doesn't have a gray hair in his head. Like, and he doesn't put any chemicals up there either. So. Yeah. 60 this year. I probably shouldn't have said that. They're like, you might be watching a live stream. You never know, right? Hi, brother. What I really wanted to do is talk about power supplies. This wasn't my idea, but basically, well, let me tell you a story that maybe not keep it bored. Remember when we introduced the compact 200 series IO? Okay. So when we introduced the compact 200 series, we also introduced a power supply called the FPS 480. And there was some expectation from I don't know if my leaders, my bosses or whatever, hopefully they're not watching on the live stream, that when we introduced that FPS 480, we'd take the FPS 400, which you had out here yesterday, and we'd move that along in the life cycle. So we have one power supply and they're both made by TDK Lambda. But I didn't do that only because, it's like, let's give it at least a year runtime before we move anything along in the life cycle. So if you look at the sales of power supplies today, which I still haven't moved it. We're still selling the FPS 400 in greater quantities than the FPS 480. So someone on the procurement team, they have their own initiatives. They want to save. And they said, well, we could get another power supply from a different party and we could save money on power supplies. And I'm really I said, wait, you mean don't sell the TDK Lambdas anymore? I mean, we've got a long history. They've been really, really, really good from I'll say, reliability point of view, both the 400 and the 480. And I guess what I'm looking for feedback on is how receptive would this crowd be to if Schneider or Foxborough introduced a new power supply. And in my mind, I'm thinking like, well, we got, the maintenance guy, knows the 480, works with the 480. What if we just said, okay, we're not going to sell these anymore. We're just going to sell another party Lambda supply. Then you'd have a mix and match of power supplies in your field. I don't know. Basically what we want to do is basically go through a qualification cycle on the power supply. And I know this only has one output drop, which is right. So let's assume that we're gonna do a like for like as far as functionality, environmental specs, and do a full qualification. But you could get a power supply at a cheaper price. What I'm just looking for. What I'm looking for is some quick feedback that I can take back and say, okay, let's go ahead with this, or let's not. I mean, I would certainly not kill one and then introduce one at the same time. I would have like 2 years or 18 months between the two.
For the FPS 400s. So if you would build one larger power supply and have 8 outputs,
more outputs.
More outputs.
more outputs. Yeah, we did it our technical sales consultants. We did an analysis between a global analysis between the 400 and the 480. And most of the points, the 400 came out as being a better power supply because of number of outputs. And there are other things there too.
I still got a couple of power supplies running in my DCS cabinet.
So we can do equivalent outputs. Okay. Oh, the same cable. Okay, well that's good feedback. We would need the same. We can define it, right? We can define. Right. You'd have to rewire. Because the 400 and the 480 do have a life cycle. I believe they have a life. They're in the life cycle. Well, we had a problem with lead time last year. Remember? Where's Roger? Yes, remember we had a problem with lead time, and I didn't give you a good answer. Right? We haven't. No. We haven't decided. We haven't really. We're basically going.
Right, and so you're buying extra for your license.
Well, it's kind of a catch-22, right? If we go this way and get away from those connectors, then our migration path from one power supply to the other just became
into the other one, came out in details that could be landed on one of these, so that you don't have to do, I don't have to rewire or refigure that. Be okay with a solution like that.
Like a molded plug, you just cut the end.
Well, I mean, that they give you one with some, flying leads on one end and a molded plug go into your existing cables on the other.
I see nodding. I don't know if they're nodding. But they're nodding. So let me just summarize everything hurt. So far we said we don't have to want to rewire our cabinet because of a power supply. You want to get away from those connectors because of cable length, and then there's the made an adapter. Yeah. Yeah, we're assuming we're gonna have enough connectors on this one, but because one connector, I don't know.
It's cheaper.
Let's say 60%. Yeah. Right, that's a good point. They don't cost a whole lot to start with. Well, don't. Yeah.
What's its?
Oh gosh. I honestly don't off the top of my head what the current. Let's say 30. But I'm guessing. Let's say
Something of that form. You're gonna get that kind of.
we we'll put that on the 10. So the question was the current output on the existing 480 and the 400, and would it be? We're assuming we're going to get similar specs out of this. 20. I have to go look at I got a comparison chart that the PSCs did. The status taps. Okay. I should be right. I think Marcel's writing all this down, I hope. No? You know, you can't have software without power. Can you? Like the 1 minute, the guy that plays the harmonica and the drums and the guitar and sings all the same things. We capture all those. He's a good friend, you know. Roger.
I'm good with it. If they got the same cables,
Yeah.
but the mounting on the FPS 400s,
Yeah.
I hope these I've come close to beating them apart with a 20-ounce shot hammer. So the new ones, if you just make sure they go snap on the DIN rail.
Okay.
It's not a technical thing, but
It's a very technical thing, especially if you're the person trying to fix it, right?
to get them unsnapped.
The little white connectors.
There's a little copper-colored flat metal plate that snaps on the DIN rail. I've gotten to where I've got a special 7mm driver, and I just pull all the screws and pull them off to be able to get them off.
You're talking about the DIN rail mount.
PS 400 goes to the DIN rail.
Yeah.
It screws to the 400.
Right.
That's what he's talking about.
And once you ever get them snapped on, it can be almost impossible to get them off unless you've got the 7mm.
One way that was, it got the extended full plate on it, so it's not, the old ones, you had to go behind it to put the new ones, have actually got an extended full plate on the side, just to screw out there and come out.
Okay.
Yeah, but they don't pop. Hundreds of them, lots of times, because the tolerances are so close when they snap on that DIN rail. If they do unsnap, you'll never get another one to snap back on the DIN rail.
No, because they don't fall off either, right? As
Say they didn't want the same connectors. One person saying they want the same.
So we need the option of both, right?
Put it on and then snap your existing cables into it. I think everybody was. That's what we're doing.
Would you go with a new power supply if you weren't? Let's say we didn't force the issue through life cycle, right? Let's say we're offering both for. What would you do?
Reference. Yeah, put them on PM plant.
That's what I've got a 10-year spreadsheet that turns red when they get 10 years old, and I've been preemptively replacing,
Okay.
which is why I use so many of them.
Okay.
For the FPS 400s.
So we sell two today, basically for like the control and IO platform. One is a 400 and one is a 480, right? And the 480 was introduced when we introduced the Compact 200 series, and we just kept them both because the 400 outranks the 480 in a lot of different categories like power distribution, heat's another one. forget what the other. This is all. I've got a whole chart. That's why I didn't know the output current. So this would be to replace probably both of them eventually.
Yeah, we have a FPS 240.
Oh, 240.
240. Those. Think of something. We got a huge price increase on those. Huge price increase on those. But those, I don't think we're looking at doing anything with those right now. There's not many of those. The 240s. There's not many of the 240s.
The preference is the FPS 400s to use in the field rather than the 240s. It sounds like.
Yes.
Okay, it is.
100 watts, 16.67 amps.
16.67 on the
400.
on the 400. What about the 480?
480. 481.
How many amps? 20 amps, and this says 20. So
it's kind of close.
I think you can get a lot smaller form factor and still get 17 amps out.
Okay. All right.
All right.
To summarize.
You need to have as many connectors as the current power supplies. You need to have at least the same output specs or better for amps as the current power supplies. You need to connect to the current cables that you have on installed systems with the same connectors, but an adapter cable might be accepted, but most people seem okay with that. And then we needed to have a power monitor tab on it like we're doing in front. Anything else? Anything I missed?
Yeah, don't leave it 24, 122, 40, 40, any of the volts, don't leave that unless that's what it is.
Okay.
Oh, for the name?
Can I ask?
Yeah.
You said you place yours every 10 years. Is that the life cycle that you've
Yeah.
seen?
The 480.
Yeah.
Okay.
480 is the thing, right?
Okay. Yeah, we've had a few. I just never knew the frequency of the monitor. We just been replacing
It
it.
just came out of my head.
Yeah.
Okay.
Good point.
It seemed like a good price.
Okay. Okay.
The ones that I
We got one more.
We're fairly.
No, this
No,
is
this is great.
Yeah.
I didn't
I didn't want.
all I wanted was like 15 minutes, and this was I just wanted to take some stuff back to the fort with me. Yeah, you can unplug me. I didn't have any many slides. All right. All right. Thank you. Appreciate it. This is on. Perfect. All right, so this is a little bit of a lessons learned for us that we ran into in a couple places where they're specifically the host machine for a Galaxy CP and an ICC CP were on the same box. So it's hosting some that were configured in ICC and some that were in Control Editor. So real quick, we'll talk about what is the problem, what do we see that we were trying to fix, what caused it, how to recover, how to prevent. So the first time I heard about this, we got a call from a customer seeing this very helpful error: cannot access or evaluate SFC data, I think is what that says. So obviously that led us right to this problem that had nothing to do with SFC. But we did some digging, and at a completely different site around the same time, coincidentally,
we found that they had an entire CP just missing from CSA. It was just everything in that CSA had been out. And I think on that one is where we kind of got the clue that it was right after they were running backups. So they were running ICC print and save alls on all their CPs, which is where we get into the fact that they had some Evo CPs and ICC CPs on that same host box. Did I say ICC twice? Oh, sorry. Excuse me. Control EcoStruxure Foxborough Control Editor. So with some digging, we found that anytime you quote unquote open a CP from ICC or the ICC API, that it was causing this problem. So that means obviously ICC uses that. If you were to open it in ICC, that's what the safeguard file protects you from. But also, and this is not an exhaustive list, but ICC driver task, ICC print, save all, load all, check DB sync were the ones that, you know, off the top of our head, we knew used this API and would cause this problem. And in particular, all of those, this CP was, at least at one of those sites, probably both, the CP was in the safeguards file. So you couldn't open ICC, but it doesn't stop these command line utilities from opening that CP with the API. So digging into that a little bit, we, you know, created checkpoints in our VM and tried to break it. And what we found is anytime, even if you open the ICC driver task and open a CP and close it, exit, that when you open that CP for connection, it's looking for this work file, which the path is there, but it looks for that. And if it doesn't find it, it's almost like it's trying to clean up an initialization. It wipes out everything in the CSA for it. It creates that empty work file that it didn't find. So it's, you know, which is why we think it's somehow trying to clean up an initialization in the 90s or something. And then, yeah, CSA was the notable one. And we couldn't track down exactly why that broke SFC, but something in that process caused a file to be corrupt, or it couldn't find a file it was looking for. So that's kind of the cause and why the problem happens. This is obviously an issue that we wanted to fix. We found that the recovery is pretty simple. You just, in the Galaxy, as you can almost probably see in that picture, you just find the CP, right click, deploy utilities, synchronize DBs. And that's a kind of built-in, I won't call it a utility, but an option in Control Editor. And it compares the Galaxy. It's typically comparing the Galaxy and the CP and looking for differences. But we found that it also looks at CSA and synchronizes those. So if everything's okay in your system, that's a quick and easy way to fix this problem. It adds everything back to CSA, and you shouldn't have any differences in your CP, you're good to go. Potentially, if you have I'll give the warning that you could potentially have something that is broken but still working, that it fixes for you and causes you to have a problem immediately that you wouldn't have found out till later, right? It's comparing things and it's fixing them. And there's a lot of ways it can be broken but still working. We haven't actually had that issue anywhere, but there's a potential for it. And if there's something in the CP that doesn't exist in the Galaxy, it just gives you a warning about those. It'll, in the output, say, hey, this exists in the CP, but not in the Galaxy database. So pretty quick recovery from that if it does happen. And the last quick thing that we kind of thought about is, you know, how do we prevent this from happening? You know, obviously, if you never run an ICC driver task or any utility against a CP that's hosted from or configured from control editor, then you won't have this problem. So the first kind of prevention thing, make it less likely to happen, is it's probably, I would say, a best practice not to host, if you're in the middle of converting your CPs, host those control editor CPs on a new box if you're able to. If you're doing online conversions, that doesn't really work, but if you're able to, that's just a little bit less likely to happen. The other thing that we found is this problem only happened one time for a CP, because it goes in, it sees the work file isn't there. Let me back up and say for anybody, the work file is what ICC reads and writes from. So that's obviously not there if you're not configuring it in ICC. So if this only happens once, the first time it does it, it goes and creates the work file, just an empty work file, and it never happens again. So one way you could do this is go through at a time when you feel comfortable, cause this problem, and inoculate yourself, if you will, cause this problem, fix it, and then if you accidentally run ICC print or save all on that CP later, it doesn't matter. You'll just get an empty ICC print file, for example, and don't worry about it again. Quick, easy, to the point. Any questions about that? Has anybody else had this issue? It took a while for us to run into it because I think most people don't host their CP galaxies on the same box.
May I speak up?
Yep.
So I want to point out that the experience you had is actually great because the recovery seemed to be easy. So that's good news. But I want to point out that conceptually, when we move from ICC to the control editors, this is a move that is meant to be one time and permanent and final, right? So you could say, well, why did the people from Schneider not lock it down better? For example, look at the work file and then treat, the failure mode better when it's not existing. The reason is that there are situations without control editors where you still might want to have access and you don't want the software to lock you out because you lost the file or whatever reason. So we made a trade-off decision on what to do here and how hard to lock it down. But we couldn't find a solution that was absolutely foolproof. So long story short, once you decided to move with a CP from ICC to control editors, you never should even attempt, right? Using one of the legacy tools, including ICC driver task or the ICC itself, to do anything with that CP. Instead, there are other tools in control editors that are supposed to be helping there. One of them is the direct access interface, which uses XML, and it's different, it's more complex, I get it, but it's also more powerful. And of course, you can do save vaults from within the Galaxy and export the database as a save vault still. So it's not like you can't do this. And you can even trigger that with direct access. It just needs a little migration, but it's not rocket science. So that was my high level comment from the vendor point of view. But I'm actually happy that you found a quick recovery.
Yeah, I think both of these sites knew that it wouldn't work. But knowing that it wouldn't work and knowing that it's going to break something are two different things. And it was an automated backup everything script, and it just saw that CP and acted without any thought to that. So since then, that you can improve that backup script, and maybe that's a takeaway too, is improve your backup scripts to. John's not in the room. I think what we settled up on is looking for that work file, and if that work file didn't exist, we skip it. There's a couple ways you could check for whether it's hosted by the Galaxy, but I think that's what we settled on. All right, I think it's another question. What's up? Yep. Let me back up. That was one of the ones that was a little surprising, or at least not obvious. Check DB Sync is the last one in that list. It uses the ICC API for something in there. Yep. Yeah.
ICC connection to a CP. But then you get this problem if you try to go into it with the control editor. Then after you've been in it with the control editor, can you not check DB sync?
Yeah, so you know, your conversion process, it's all in ICC. You typically, if you're not trying to do it online, you export that, you know, convert it to the Galaxy and initialize your CP in ICC, safeguards, deploy from the Galaxy. At that point, it's configured from the Galaxy. You shouldn't, at that point, use any of these utilities. Or try to open an ICC, and the safeguards file stops you from using ICC. And the first time you try to use any of these utilities, and specifically anything that uses the API to open a CP, it'll cause this, you know, it'll break it in this way. And then synchronized DBs fixes. What's that?
You say it will
it'll cause this, you know, SFC error, clear out CSA. It'll, the first time you try to run any of those utilities, it'll cause that problem. The synchronized DBs that we talked about will fix it immediately, and also at that point it doesn't cause the problem again. You know, I'll call that a workaround. That's not like a documented feature, but we found that, you know, it just at that point wouldn't cause the problem again because it synchronized DB doesn't go and delete the work file. As far as ICC is concerned, you've got an empty CP sitting there. There's a work file with just the station block and the primary ECBs. So that's enough that it doesn't go and try and initialize or clean up some initialization when it
prevent you from doing that. And when it, what did you say it does to CSA again?
It cleans up all the compounds and blocks that are assigned to that CP, so it deletes them out of CSA.
But it does it wreck CSA?
No, it doesn't affect any other CPs other than if they spin up and try and go to CSA to, yeah, it basically it's the same as if you initialize it. Yep, and only the one time. So if you go through and, you know, you can deploy just the primary ECBs and the ECBs when you first convert to the Galaxy, deploy just the minimum, and then synchronize DBs, and then deploy the rest of the CP. And you've sort of prevented this from, you'll still not get good results from ICC print. It'll just show nothing, but it won't break anything. Yeah, and like I said, the symptoms don't always point you right to the problem, right? Because the SFC one was not obvious at all, and it might take you a while to realize that missing CSA entries are your problem. It would just cause stuff not to start talking weeks later, probably, right? The next time it made a new connection, it would go out to CSA for that compound and find nothing and just wouldn't resolve. So neither one of those symptoms would be easy to diagnose, I don't think. All right. Do we have a break next? Is that lunch? Is lunch ready? Awesome. All right, lunch is ready. Go eat, guys.
Test, test.
Okay.
Not sure. It works fine. Thank you. Okay, good afternoon. After a good lunch, we continue what we ended yesterday. The goal is today that we present another part of our software. And so, yeah, let's go. Maybe just for the record, this is Koen. Yes. Maybe hello. Present you first.
Hello, hi everyone. I'm Koen. I'm an AI and automation engineer at Telsoft. Just so you know, if you have questions during the presentation, just feel free to ask and we'll answer directly. You don't have to wait till the end of the presentation. Okay, let's go.
Cost, but in there, the first part, the templating structure, was only a little bit filled in. That's why our best, I'm not hearable. Oh, okay.
Is it now better? Ah, yeah, now I hear the echo. Great. Yesterday, for the reduction of your costs, the first part, templating structure, our other package, T-Star Control, with the web view and the trending, yeah. To be honest, it has nothing to do with real structure. Maybe the database internal can be structurized. So what we mean by templating structure is more related to the control. So how your control loops are built and how is it possible to maintain that on an easier way than just everything in flat tag by tag generation. Okay, so yeah, the rest of the items I just continue, but the goal is after presenting this tool that we are seeing 100% coverage for our part. Okay, so now I would like to present the control engineering tool. It is in fact based off for a number of customers. We were also working with the Orchestra IDE. It has a bunch of nice and good functionalities. So I should say it's really worthwhile to convert your ICC and integrate it into the IDE. But still, even with all those fancy things and the graphical things, we find a couple of points that can be improved. And that's always also on our software, we figure out if a customer uses it, then he always has remarks, but is that possible, or is that possible? So for me, it's normal that a tool is never perfect, but if you work on it and continue on it, well, then everybody is happy with it. Okay, well, one topic that I think a couple of guys will admit that you have to be, let's say, a specialist in the Foxborough to do modifications in the IDE, orchestra IDE. You have to know how your control is built, how your strategies are created, also how you do the deployment, and what happens when you execute a deployment. Is your CP going, restarting, let's say, or your sequences are reinitializing or not? So it depends on what you are deploying and download, what really happens with the operating system. Okay, but then the next point is that strategies are easily defined, completely graphically. You can very easily, I have an analog in block, I have a RIN block, link them together, and your strategy is up and running. But what is missing in the whole setup is that you have not the ability to add, let's say, formulas to your strategy. You cannot, like in the IACC package, define my deadband is based on 2% of the min-max scaling. Those things, I heard yesterday that only few guys are using IACC. In Europe, there are more installations of the IACC, and Lacos then they went to IDE and they say, yeah, but my formulas are gone. And so now they had to type in, when they change a scaling, they have also to modify and calculate the deadband, and so other little stuff, other little items. Okay, then next there are grouped actions. In IDE you have a little locked parameter field, very nice, very handy. So it means, for example, you specify in a compound your group devices for the alarming. And instead of editing every separate compound that is related to it, you can just create a master compound for a certain unit, define there your devices, and then set the lock on, and then all your derived strategies are related to that parameter. If you need a modification, unlock it, do the modification, and then lock it again, and that new value is distributed automatically to all the underlying strategies. So very powerful, very good. But at I am a customer, a certain place, they had a problem that one compound template was related to 2 units. And what happens if you modify that, then your 2 units are all modified. So at deployment, you have to deploy the 2 units. So for us, it's a nice feature, but yeah, be careful when you are in control and handling it. Okay, another functionality is that configured parameters in the strategy, well, they cannot be guaranteed to keep the same. It's a little like the formulas, but suppose you have a RIN block and an analog in block, and you say, okay, I put some alarming on the RIN level for the bat with levels, the limits on it. Well, you have to also set the same values to the analog in, if that also needs some alarming for or other parts of it. So it means in your strategy, if you do a modification, you have to know, okay, which parameters do I need to set all right? In ICC, okay, it's obvious, then it's all, you know it. in IDE, you get the impression, okay, the system does it for me. Not always. That's a little the game. Okay, then, but another lack is tag lists. Again, in the ICC database, there is a possibility that you say you create an Excel-like file with some columns in it, define the parameters, and then you can say, okay, build my control based on those tag lists. In the IDE, there is something like a bulk data functionality, but then you have to write scripting around it to define all the special things in your blocks. But again, that mechanism is working like not as it should be, in a way that if you do a bulk data generation and you do a modification of a certain parameter in your bulk data list, well, then the strategy is recreated. But if you recreate a strategy, a lot happens. I think, David, you, you are aware of it too. So what in fact happens is that if a strategy gets deleted and then recreated, visually you don't see nothing special, but there's also called something like an execution order. And that, from time to time, is also important, in a way that if you're in IDE, you have in fact two levels of strategy of execution order. You have the block level, we call it. So inside the strategy, you say first my RIN, next the analog in, and then eventually the GDEF. If you switch that order, even in ICC, it can happen that you get a blue field because the order of the sequence of your data is moving, is not right set. In IDE, does not solve that automatically, so you have to set a kind of an execution order correctly. That's based. And then a second level is that all your strategies are related near each other, and then there is that so-called compound order. I'm not sure whether there is other naming around it, but it's just the order of all your compounds are. And then if in IDE you say, okay, I'm going to delete the strategy and add the same, but at the end, your order has modified. The moment of a deploy in the CP, there is an existing order, and your IDE needs to, I call it recompiling in a way. And from time to time, it takes an hour or longer before you get your download ready. Everything at the end runs fine, but there are still always things that if you want to do something quick and such things happen, then the time is blocking you out. Okay, well then another part, change management. We find it very important that if you do a modification and in future when all those, it's not directly related to CRA, but you have to have a tracing of all your actions and handlings, or you keep it manually, but nowadays, it's too much to change, so there are systems that do it automatically. So I think probably in future releases of the IDE, the change management will be added automatically or in a separate package, but we find it important, even if you work with multiple engineers, that you know, okay, who did what at a certain time, if there is a certain problem that arises. Okay, and then a last point is that it's related to the mechanism of strategies. So the main idea is that you say, okay, I create a template, and based on that template, with some blocks in it, some parameters, some default items in it. So, and based on that template, you can do create a strategy derived from that. But if you have already a strategy in your system which has no link to that template, you have no possibility to link it. So you cannot say, hey, now I'm going to create a template and I'm going to link that strategy to that template. That is not possible. It's normal in a way of how the whole mechanism of classes and objects are working. You cannot say, okay, there is a derivation of it. So you first need to create the master one, but in control, you have a little the problem that if you do an uploading of a number of strategies already in the system, yeah, you cannot make a model with templating and then link it all. Okay, so those are top of items. And yeah, for that, we set, because we were working recently, or we are still busy on it, to convert the ICC, in fact, it was an IACC database, how to convert it to the IDE. So normally what is done is you use your, let's say, save all work files, upload them, but then you get that, we call it, you have only a number of flat strategies. So the strategy is based on your loop ID, because that gives an ID. So first of all, it's good to write or check all the names of your loop IDs, are they set right? Because in ICC, it was not a requirement. It was a nice text field, but and when it's not used, well, then all those blocks are just put in one big strategy with no relationship at all. On the other hand, if there are relationships found, links, source links found, yeah, then they will be created in that loop automatically, and you will see it. So the end is, for most of the strategies, you see nice the data, can modify it, deploy it, and all works fine. Okay, well, I should say, Koen, I leave it to you to give more details of the tool.
Yes, okay. So to fill in the gaps Lieven just mentioned, we came up with a solution for, first of all, gain some structure in your control, and next to make it way more simplistic than it is right now. That's why you see here a new approach. You can first, I will say that our approach is, you can really see it as a layer on top of control ID. It's not that we are replacing the IDE, it's a layer on top. And this allows a lot of functionalities that we will show directly. So first of all, how does it work? You have to set up a configuration for all your structures, for all your templates of your strategies. Using this configuration, you will be able to extract and eventually upload the data again to IDE. So first of all, if you want to gain the data from control IDE, we will extract it using the templates, using of the strategies. Then our tag list with all the strategies will be filled in. I will show this later. And then you can make some adaptations how you want. You can make some changes in whatever parameters you would like. And then you upload it again to IDE and can even deploy it to your CPs. Okay, so with this being said, why does this bring so much structure to your IDE? We create these, the templating structure is really based on a technique that allows you to set a layer in between of your strategies. First of all, for every template, you set up your configuration, and in this template, you have like your static variables and your parameters and your dynamic ones. And the static ones are the ones in one template that always stay the same. So why would you want to see them over? Why would you want to handle them? They are always keeping the same. And if you would want to change one of those static parameters, you can always do that. And that also I will show directly in the demo afterwards. What I'm trying to say here is that only 1/3, when we did the research after it, we saw that 1/3 of the parameters are actually dynamic in those templates. And with dynamic, I mean they fluctuate, they differ in this template over all the strategies. And so 1/3 of all these parameters you have to handle only. So you diminuate your parameters to like 1/3. That's already an engineering cost that that allows you to to diminish. You can reduce it to that. So that's also a main reason why the structure of templating is so important and is so handy, because it allows you to reduce your costs immensely. Okay, so what is it all about? Our engineering application is a desktop application that allows you to, first of all, we need to set up our. So we define a template. What is the template all about? It's a list of blocks, the blocks that are in there. You have the default values that you set up for all your parameters in the blocks. You have the block parameter links that are in between, parameter definitions. What is important, that is the tag headers. The tag headers are really for the dynamic parameters in your templating, because they will eventually be used to, when you extract your parameters from IDE, you will put them into the tag headers. The tag headers, also the dynamic, the 1/3 I mentioned before, that that you will use to make changes and stuff. Then the block parameter definitions are more like to generate afterwards again. So when you generate again from your tag headers into your IDE, you have to make sure that everything is filled in rightly, and that is done by using the block parameter definitions. Then some last extra step we also allow is that you have a list of historian parameters, so you can also define them in our application, and then they are loaded directly in. Okay, I give an example. Imagine we are extracting from IDE, and we are filling in a tag list of ours. So these are all strategies, and the columns are all the tag headers. When you see that we have like 3 tags, processor compound, and we will be changing the alarm limit, the high one and the low one. Imagine we want the lower limit set to 5, and the higher limit we want to set to 100. There was nothing. What will this do? When we build this in our application, we see that the tags will be set. So the value is set to 5. The IDE value is still 0. The CP value is apparently also still 0. Then the lower limit, no, this was the lower limit. The higher limit there is set to 100, and in IDE and CP there is nothing there. What is also interesting, your higher or lower option, so the H is also set directly. And how does this work? I will also show this example into the demo, that you see the formulas behind it, because that's also a really important thing in our application, is that the extraction and the generation is based on our formulas that Lieven already mentioned, that how they are loaded into our application, and eventually how they are generated again to IDE. Okay, so eventually we will upload this to Control IDE and can even deploy it to your subpiece. Why is the application pretty nice? You can reduce your parameter handling immensely. You gain a structured and cleaned up control. I will also in the demo mention that there are some features that allow you, for example, to make sure all your engineering units always are the same. That's a little detail. When you set up a certain compound block address, sorry. Okay. When you set up a certain compound block address, you don't want to guess or write it over. You want the application to help you to do this. When you want to select a certain processor, you also would want your application to help you in this, and these functions I will directly explain. Then why is it also very interesting? It's just fast, it's simple, and you don't need that much knowledge. Yeah, you need some knowledge obviously, but everyone I think can set up some or tune your parameters as you like, and it's really visual, so it allows you to directly change it and to show you the differences. Okay, then before I give you the demo, also management of change in our application. So in the configuration and in the data part, we both make sure there's a management of change. So every step you do, every save you do, every upload you do, every extraction you do, it's all logged by who and when. So you can always find out what the problem was of who did it and where it occurred. Lastly, then there is also a privilege-based login, such that you can tune out buttons, you can read only, set things to read only, all that stuff, all possible. And yeah, then the maximized input help. That's really to help you guys to set up the parameters. Like for example, if you have to fill in a parameter, but you already know which block it is, it already gives you some examples of parameters, and then you can fill it in and click on them. But I will also show that in the demo. Okay, yeah. Before I go to the sequence debugger, I will do a little demo. Okay.
Maybe in the background, as said, we use this tool for ICC to IDE to get the structure, but it's related to IDE. But I think, as I heard, there are a number of ICC installations. Also from there are possibilities to do some, first create your model of platform, let's say, not directly related to your controllers. Prepare everything and then build in that way your IDE, and then check that every parameter that is in the IDE compares to the CP is equal. And once that step is finished, you are sure that your control configuration is in line with the CPs.
Yeah. Okay, cool. I don't know why, but my screen is not visible.
But it's fun.
Yeah, put it in. Does he know? Do you know why the AGMI is not working?
Keep it in.
Sorry. Yeah, PowerPoint is closed, yeah.
Some technical
Oh shit, we're not there yet. Yeah, I already tried to. That's weird.
Yeah. Okay. No, it's on your PC that is not working. Oh, it's coming back.
Yeah. Yeah, that's right.
Okay. Okay. There are some zoom in options in it, but I think the screen itself Yeah, or we can use a TV of the demo room.
Okay. There's no lights.
Okay, great. David, it is okay that we continue? Okay. Yeah. Okay. Great.
Okay. Okay, perfect. So here's your application. It's a desktop application, but also possible in a web application, so online. So how does it work? First of all, we have like 7 tabs. The first one is for the tag headers. You'll see here that we have our header names defined, different blocks, the parameter value that you want to put in the tag header, and then the formula if needed. So for example, to stay in the example I explained for the alarm limit, the high one, you see here the formula that we will be using upon a build, upon extraction, because this is really the formulas we will use for extraction, and then I will directly show you the formulas for the parameters.
Maybe Koen, can you keep the screen of tag header, because I think one important thing to know is you see the column block. Well, that is in fact in the IDE, in your strategy, the default name of a, like you said, by default it's analog in, so that block is named analog in as a default template. It can also, because it can happen, you have multiple INs in one strategy, and then you give it your own custom name. That name is important, that what is placed here is the same as in the strategy in ID. And then the parameter is then related directly to the block of that strategy block. And so that's, in the naming, we have a strategy that has one or multiple strategy blocks, and each block has then its parameters.
Yeah, and additionally, we also have the availability to put in a data type. Like for example, if you would want it, if you mention that it's an integer, then we take this into account when inputs are done, that it's an integer. We also have the availability for an help list. That's what I mentioned earlier, that for example, a user can put in here like a certain name of a list that is configured in the settings. Like for example, for a processor, there is a certain processor list. For the engineering units, you define all your engineering units in the configuration settings, and you just put it here as a help list. And then afterwards, when you plug in the engineering units, you will be able to just click them, and you don't have to, you will always be sure that it's always the same. Also, another option is for the addresses.
Yeah,
maybe you
addresses, so that you can get a screen of your compound block parameters, search in description, and then you can just select your address from the link. Also interesting in the help list is that like if you need to configure the in Helm, so it's 32-bit hexadecimal, in ID you have the buttons, the detailed buttons. And we provide also then such things similar, so that you do not have to calculate through a program what is the real value of your in-Helm parameter to set a high active.
Okay, then before I show you the template, you also can plug in some blocks and so define your blocks, the extensions. You can also add some links to them. These are then also visual available in the template. Here you see the link you defined. The use of this template will be made sure later. So then we have the parameters. These are like your, to generate again, to upload again to IDE, you will use your parameter definitions. These are actually these formulas are kind of the inverse or opposite, but it's a little different than the ones in the tag headers. So here you have your block, your parameter, your tag header, and then the formula that is used to plug to use your tag header and use that data to put it in your parameter of your block. So the links I already mentioned. We also have the default values. That's just a long list of all the default values of all the parameters, block parameters that are available in this strategy, in this template. Here are like only 2 blocks. So we have 2 blocks and all their parameters that are defined in here. And then we just set a default value. And this default value is very handy for all the static parameters, all the ones that stay the same in your template, because every time you create a new strategy, it will already directly take in those default values. And I'll explain in the data page what these default values then also can do. Then we also have the Wonderware Historian tab to put in those.
Well, typically for the Wonderware, what you do if you have, let's say, that analog and RIN block, that you say by default, well, I want to have the PNT value directly in your Historian configured, so then you don't have to worry to additionally mark it for each strategy. Is done automatically.
So then we can also add some changes to our configuration. I will right now just really out of nowhere add something. You will see here that I added a block. You already give me some input knowledge. Then here, since I added a block, he already allows me to choose a parameter.
Maybe choose one, the compound, but
then I choose again a target block. So we really try to guide everywhere in our application. We really try to guide the user as wide as possible in every option they take. And then if I would save that, you'll also see this on the other page, we always have an assurance or availability to look again at your changes. It's not a direct save. It will show you in all the tabs, like right now we made some changes in the links. You will see, okay, yeah, indeed, I added the link, and you can even click them out if you have multiple changes and you saw, no, I don't want this. You can then save as a new version, even add an optional description. I will right now just save it as a new version, and you will see why. Why we have a version control later on. Okay, with this being said, so we have our whole configuration set up. Right now we can go into our data page where we have then...
Okay, maybe just in the configuration, because you weren't talking about the header, or will you do it later?
No, you can.
Yeah. Okay. Well, for the structure in the hierarchy, what we provide is, in fact, okay, you have an area, and in an area you have one or multiple units, and then for a certain unit you have one of more templates. Okay? So that's the strategy of how it's structured in the tag list view.
So here indeed you have an area, you have a unit. When I look into our unit, how it's defined, you can see the CPs we added to it, and then we can select our templates that we want to be visible. And then here we have then all our tag lists available. These are all the tag lists based on that certain template. So within this template, for example, we have like 78 tags. So in this way, you can easily see all your tags or your strategies of this template. You can even make some changes. So like, for example, if I would go into details here, you have a little nicer view. And I would want to try to change actually, first of all, I want to show something else. Since I have changed the configuration, the reason why we have a version control is here. You can see it then. You can choose to hold it on that version. But for example, if you made a new version of a certain template and you don't want to deploy it yet, you just keep it there. If you want to integrate it into your IDE, you have just the possibility to synchronize it. When I would synchronize it, I would also see what the changes are, so the differences are between these two configurations. Like for example, I just added a link here. I can add synchronize. Et voilà. Then the configuration is put in and it's synchronizing.
Right, so in this case, all those tags, all those strategies are added with that new link, what was put in the configuration.
Yeah.
So for it means also that if you are on the data tab, that data tab works with a certain version of the configuration. In the meanwhile, you can do changes and save it as a new version. But once you say, okay, I'm going to the new version, then there's a requirement that all your tags are in sync with that new version. And that's why this step is intermediate.
Yes. Okay, so to show you why there is an extra params list here, I will make an additional change to the default values of one example. 1 second, and then I will explain. What was it?
OSV also. Pick one that is not used so that you can really see it.
Okay. I'll just take this one, put it at 4. Yeah. Okay. So if I would change this, so I save this even.
The same. Oh.
Yeah. Doesn't care. And we would then synchronize first again. Or no. So what I will now try to explain or show you guys is that we changed the default value, because I explained we have the tag headers. These are all the dynamic parameters, and then we have the static ones, and those are the ones that are always the same. But of course, it can always be the case that you have an example of a certain strategy that needs to use one of those static parameters. And that's why we have an extra parameters list that allows you to make or add this parameter, and to show you, I will directly show you upon extraction, it will then automatically flow into that list. Like for example, I can extract, this is an extraction with the same configuration if you want to work for the same configuration, but right now I want to make use of the new configuration. We wait some seconds, everything gets extracted.
So what happens in this case is that we go to the IDE and extract all those blocks and then put it in this configuration.
So right now you will see here that our OSV parameter is set to 2 for this strategy, while our default value said it was 4. So I changed it to 4 because right now you see that the change has been fluctuated to our extra parameters list to show you that there is this change compared to your default list. So with that being said, what if you want to, I will make this a little bit bigger. What if you want to change the alarm limit, like in the example I did in the slide? I will set our high alarm to 20 and the lower alarm to 1. Again, when we save, the same way happens. You see what your changes are. You can add an optional description. When I'm saving this, you will directly see notification that the values in this part are outdated, because when I would build right now, so when you see that our higher alarm limits and our lower alarm limit, can I find it? So our higher alarm limit is still 14. And when I would build it, it builds directly all the tag headers. So these are the generation or the upload formulas for the opposite of the extraction. We use those formulas, and then it gets put into our resulting parameters list. Here you see that in the higher alarm limit, it's set to 20. And if I would go into detail for this, you would see that the value is 20, the default value 0, IDE value, CP value at a certain time. And you also get a description of what it's all about, the high alarm limit. I think we all know, but we even have the optionality to dive deeper into our documentation. And here we'll see that that's weird. Didn't it directly open it? Normally, so this is our documentation of the application, and normally it should open directly on the page of the high alarm limit, but for some reason this seems off.
Yeah, link is gone. Okay.
So
if you click on another one, let's say.
I'll take the bad alarm group. Et voilà. Okay, so it takes you directly to the parameter you want some information about. So what we did is we are capable of interpreting the PDFs, and we interpret them, and this allows us to first then generate. So you could put in a PDF, and then we are capable of analyzing it completely. We structure it in our structure, and then we are capable of directly linking it, and that's why you see it directly here. The bad alarm group with all the context around it. If you would have some bit numbers like in the block style, would be directly guided to here, and you would see more about that. So that's nice if you also want to know something more about the parameters here. Okay, with that being said, you might ask, why are those yellow? These are all your IDE differences, because we can always track our differences with IDE, since this is a layer on top of IDE, and then also track the differences with our CPs. And that's where we use those two colors for. So you see directly, okay, these are still changes with IDE. So if I would want to upload them again to IDE, we can first check out preview. Then you see all your changes compared to IDE. And if you would want to upload them, he automatically uploads them to IDE, and you can even deploy them. Okay. What is also a nice feature is that everywhere, not only in the configuration, but also in the data page, you can export and import the tables to Excel. So if you have to do like large modifications and you're like, okay, I want to just use Excel for this, it can. You just extract them, make some modifications, you input them directly into the tool, and it will show you a screen like the save options, what your changes are, and you can put them in. The same for the data page. Here too, you can import, or first export your tech header, or just one strategy, change it, and then see what your differences are. Here we have some statuses, like I changed the first strategy here. It's also possible to delete one, to create a new one just by copying one, for example. Why do we not directly delete it, you might ask? Well, that's very important. We only delete a strategy after we are sure it's deleted in IDE. So right now it gets the status deleted. We will first, upon upload, delete it in IDE, check it, and then we give here that we remove it. So if I would select those, I would want to upload it to IDE. Right now it's just a dummy data IDE, but I can show you on my PC that when they are uploaded, the new one is active again. Yeah, the deleted one is deleted, and then here we have the edited one that is active again. That's just a way of use that we make sure that everything gets uploaded in the right way, and you're always visually seeing which strategies you edited. Okay, so this is one view. Like we have our areas, we have our units, and then all the tech lists in them. I think mostly you will make use of this view. We call it a plant overview. And here you can make some easy searches. Like for example, all the generic columns, we allow you to search And yeah, you want to search something?
Wow. Is there also a description in the
Yeah, of
Oh,
course.
well, then let's say
Something with water?
T1 of water, yeah.
So it will automatically show you all the strategies with water, and it is not just in one tech list, this is over your whole plant. You can make a search. Right now he just shows you all the descriptions that contain water in it. You can click on one and then directly make some changes to it. And that's mostly it, I think.
Okay.
Something extra I will still say is that, so I explained already that there is a management of change in both configuration and data. So everything we do is put in here and is locked, so you always know what happened to your control.
So big brother or little brother is still watching you.
That too. Then I also spoke about privilege groups. You can just, like in the data page, if you want to give some users only read-only views, some users might not go into the configuration page. These are all possibilities, of course, if you can set it as you want to. Okay, I think I explained most of it. Do you want to add something, or?
Well, there's still some info, but I should say, maybe are there any questions about it? We are happy to answer them.
Is there still time left, David? I don't know. David, is there still some time left? Yeah.
Well, it's where we have another tool, that frequency buffer, that we would like to show, and
I
then
think 5 minutes, not even that long. Right. Okay, so lastly, we will show you an extra functionality that was really asked by our clients, sequence debugger, because we saw that debugging sequence code is so hard, and they mentioned to us, like, we always have problems struggling with interpretation. Can you help us with this? And that's when we came up with this solution. So first of all, it's like in our T-star control package, like right now integrated. You can see it here. So what do you see on the left side? You can see all your sequence blocks. In the middle, you have the sequence code, you select it, and then on the right side, there is some variable information about all the variables that are in your sequence code. I will start the video. It might go fast, but we'll see. Okay, so first of all, you'll see that in the first part, in the first, you will be able to. I will start it again. You see the compound, the blocks, the description. If the sequence code is still active, if there is an error code, also very nice to see. You can filter on them, search on them, however you want. If you then click a certain sequence code, you can just start debugging directly. So I will explain very shortly how does it work. It compiles directly when you make changes, and it compiles upfront the sequence code, and this allows you to make steps through your sequence code. You can visually see, like that's what you see right now with the yellow line, that you go over every step by step. You see what is happening to your sequence code. In this example, I can't read it very well right now myself, but the request, the OP request, right now it goes in this if-else functionality, it goes in the else. For example, it's really stupid and small, but when you check on the right side, you will see that the variable info, variable name, I just searched for the request. We see, oh, when we resolve it, goes a little fast, so I will go back. So initially you see that it's the Boolean input of that compound block, and then you are capable of, that's what the resolved functionality is for. If you have like 3 or more variables in link with each other, like for example, this variable is on that address and is that value, then the resolved functionality will directly link your first variable with the latest one. So you directly see what is in it. Like for example, right now here you'll see when we resolve it, that it becomes false. So that's the reason why it goes in the else functionality. What I do here then is I change it to true. First, I reset it. I look again, it's the Boolean input. I search for the variable in my variable info. When I have found it, I set it to true. The system will automatically compile and step by step show you what the steps are right now. And right now it goes into the first if, since it's true. Yeah, it's a small showing, but that's what it's all about. It shows you then that there's a continue button that you can just see how it flows. This is a while loop, so it continues. You can stop it. And yeah, you can really debug your sequence code as you like. And an additional feature is that you can search over all your sequence code, certain block parameter. Right now I put in test, but just you can search whatever you want over all your sequence code.
Yeah. What's really handy is that on the right side, you can, for your testing, really set some parameters in it, what the system can happen or what occur, and then debug your code to verify, okay, is the whole logic set correctly. Also interesting is on the left side, the structure, there is that error code and that line number that comes automatically from the CP. So this program can function directly on your CPs. If there is a certain sequence in error, then you can start this tool, see, oh, on line 250, there is that error, look into it, then start debugging and verifying what you need to do to update it correctly, and then it can be uploaded and you're all set. Yes? Yes, but it depends, of course, if there is an IDE in system active. Well, we only upload it to IDE, and then it's up to you to deploy it to the CP. If it's in ICC, okay, we can present, and then there are ICC driver tasks to say, okay, I want to compile it and I want to upload it. The stepping is completely offline.
Yeah, that's
we do not use any of the CPs. That's why you can easily test and modify all your things without interfering the CP.
That's our own compiler that does all the steps and checks out. So it's not the CP that's running that. Okay, that's it.
I think
we're done here.
We got.
So yes.
Any questions? Okay, well then thank you for listening, and thank you, David, for giving us some extra time so that we had the extra things.
Do you have a question, Roger? Yeah.
How could we get that if we wanted to buy it for our facility?
Is it a standalone product?
Yes.
This is seen as a standalone product, and it can be used in combination with the T-star control. To be honest, there are parts of in here that are also used by the T-star control, like the complete extraction of DBView and ICC or the IDE. But okay, that can be separated and all integrated in this tool.
Since we really load in the live values, we also use our control to load them in and so that you know which values are in there. So that's why we use it, but it's a separate package, so you can definitely only purchase this as one. Okay,
thank you. Okay, well then.
We'll leave.
Hello. My name is John Danford, for those of you who don't know me, and I'm going to make a very quick little presentation here on a quick tip that helps us out here. So this is finding bad DCI blocks. So there's a scenario, you have an FBM 232 and maybe you're talking to, another side of your plant. You installed a new PLC and you have a compound with hundreds of blocks, hundreds of DCI blocks. And maybe some of those blocks aren't talking to your PLC properly, like they have a bad point number. It can be difficult to find which of those blocks are not talking. Pretty much the only way that I can think to do it is to kind of go through Fox Select and click one block at a time and open them up in block detail display and actually see them smurfed. Does anybody have any way that they usually solve this problem if you do have this problem? Have a co-op do it? All right. Well, during this presentation, I'm going to try to answer this question, and maybe y'all will have a way to solve it at the end of the presentation. Be real quick here. So there's this cool tool called CPU-till. This is an executable on every Foxborough machine. It's in the opt-fox bin tools directory. It can do a lot of things that I will not go over. You're not meant to be able to read that thing on the right. I'm just kind of showing you that there are a lot of options on this tool, and it can do a lot of things. But if you go on the command line and you just type in CPU-till, you'll get this little help window here, and it'll show you how to show you all the options. But I'll go through a couple of them here. Number one, the first usage example, you have this -G parameter. That's the get parameter, the get command. So this is just saying that you want to get that parameter of that block. So you say -P, no space afterwards. You list your compound block parameter that you're trying to get. And then the -OV is to get the value, the current value of that parameter. It basically does exactly what OMGet does. So you're like, well, why is this tool helpful to me? Well, it can do other things as well. So here is a zoomed in screenshot of part of the picture that I showed you at the beginning there. So you have the -ON, you can get the parameter name, -OS, you can get the value status, which is what I'm going to be going into more detail in here in a second. But you can get a lot of different things here. You can get the type of the parameter, whether it's a Boolean or a real or what. And then what I showed you in the last slide was the -OV, where you can get the actual value of that parameter. So here's the other usage example. If we do the -OS here, it'll actually return the thing at the bottom right there. And it kind of formats it in more of a, user readable way here. It gives you 8 characters and it puts underscores if that bit is not true or is true, I should say. And then like the O there is the out of service bit, which is true. So this hex value here is the actual value of the parameter status. But, it's not that helpful to be able to read that. So here is what all of the bits of that value mean. And specifically in that last slide, the O was there, and that's trying to tell you that bit 11 was on, the out of service bit. But there are many other bits that we can read here. You can see if the block's limited high or limited low, or you can see if it's bad IO. And the first 4 bits there, they tell you the type of the parameter. So if we get back to our scenario here, we might ask ourselves how we can use that OS command to save our co-op some time and actually get the the value of that parameter or the status of that parameter. So maybe you can write a script and have a little wrapper around the CPU-till, and you can give it an ICC print and a compound, and it can go through every block, every DCI block in that compound, and you can get the status, and you can pull out that specific bit that we're looking at there. And in my example, I care about the out of service bit, but you could use this for other things as well. So your wrapper could pull out that specific out of service bit, and if it's true, then it could return it for you. So you run this script that you make, and then you have all the blocks that are out of service. And that's a lot easier than, clicking on every one and kind of seeing that it's bad. So I got a little test block here. So this is a test CIN block right here, and I'm doing the .in parameter with the -OS, and that's what it returns. which is not the most helpful, but you can see it's got that O there. And you can kind of parse out the different bits right there of that hex value, and you can see that the 11th bit is on when that O is showing up. Yeah. Yeah, so that's kind of the idea, is just kind of, you can use this tool in a lot of different ways, but I'm just trying to, I don't think a lot of people know this tool exists, so I just wanted to do a little quick presentation to show you that it exists and that it can be helpful in certain scenarios like this. Yeah. I'd say it's decently often. Every time you have a PLC that you're, hooking up and you're talking to a lot of different points, inevitably there are going to be multiple blocks that are not talking for one reason or another. Maybe the PLC side isn't sending you the parameter that you thought they were going to send you, or maybe it was a block that used to exist and no longer exists, so it's kind of orphaned. Yeah. Yep. Returns the value very quickly. Are there any questions?
So doing that, this is like basically doing an OM.
Yeah, so we got the server, there were multiple counters of kids and going in and linking the stuff up, buying it, all that.
Yeah.
So you're saying that they're out of service, not working, they're creating ways of
Yeah, it's knocking out failure. It's not, yeah, it's knocking out, so it's overhead on this. So right. Try to communicate things that don't. And then to create the record and failure and all that.
Yeah, definitely it's good for cleaning it up. Yeah, and specifically, if the PLC's down or something, all blocks are served. That's easy to see. But if you have a type of block, it's all on that. This stuff tag free.
Yeah.
Check.
Yeah, so there's a really good sanity check to be able to find those kinds of typos and stuff. Or if they never existed in the first place.
Sounds good.
Oh, go ahead.
I'm just gonna ask you to show it box select.
Oh, yeah, sure.
Everybody needs to know where they might see it.
I don't have a great example because this block doesn't,
That's okay. That's fine.
John broke it.
All I did was stop presenting.
That's okay, don't worry.
I don't want to see your work.
Or maybe your laptop not work.
That's why this laptop. Somebody else's laptop, I'm working with them. Perfect. All right, let's see. Yes. Oh, perfect. Yep, there it is.
Oh no, hang on just one second, I left my mouse back there. Little keypad just drives me crazy, so I apologize. All right, well guys, my name is Jeff, and we actually try to look for little things, little tidbits here and there that will actually try to help somebody when they're configuring something. And one of the things that a lot of people may not know is beat time. So we wanted to go ahead and get started, but to let y'all know, since we're talking about David is talking, pretty much all of us can relate, right? I decided I'm going to embrace it. I'm the man from Hunk. So, yeah, kind of looks like me, doesn't it? All right.
That's
right. I'll get some of that spray stuff. It'll right in. All right, since most of y'all are older, let me ask. Who remembers the display builder? Oh, yeah. Quite a few of you. So, what about the beloved display configurator? So you had to get out of the display builder to go to configurator. You realize you did something wrong. You got to go back. Well, too bad Brian Long is not here, because he would absolutely say, those were the good old days. Please take me back. So I wanted to give you a quick little presentation of display builder. If you recall, this would probably take about 3 days to build. And if you see these little guys right here, everybody knows that when you hold the mouse wrong, it's going to put something there. Well, at Southeast Paper, they call those boogers. And my boss would look at them and say, get those boogers off the screen. But you got to admit, those are cute little boogers. All right. So this process, you got an HD tower, which means high density, and you're actually going to the low D. And if you know much about the paper machine stuff, then you have a refiner that actually refines the stock. Well, when you're going from an HD to a low D, basically all you got to do is dilute it, right? You dilute down the stock. So up here, bring in mill water. You're coming in. You've got a line going into the discharge of the pump, and you dilute it. And guess what? You have a consistency transmitter that you feed back, and you control it. Well, guys, if you've ever been in a paper mill, you know what this is. That controller is in manual, because consistency transmitters are not reliable. They're not reliable at all. So what you wind up doing is having the operators put them in manual, and they kind of control it themselves. Well, life happens. So we're rocking along, and I remember this very well, that, oh, by the way, we're running along and our mill water pump shuts down. Well, that doesn't sound too scary, does it? All right, now let's look at this. The big pump is still running, and your valve is in manual, and you see where the red arrows are going? You're actually taking stock and going into downstream the filters, right? So the ones that aren't familiar with the paper industry, stock coming out of your HDs, if you can think about a pipe full of spitballs, that's what you're looking at. So all of a sudden, you're driving hundreds of gallons a minute going to your filters. What's going to happen? Oh yeah, you're going to plug it quick, right? So what is going to happen? You're down because you don't have any filtered water, and somebody gets upset. So let's see. Yep, spitballs are not good. So they call the control engineer. We actually show up and started taking a look at it, and you notice, hey, there's an AIN. This is your spitball consistency measurement. You have the controller, spitball controller, and then you have the valve. This is an easy control, right? Man, yeah. I've got this. Call me Bond, Jeff Bond, 00 nothing. So perfect. We're ready to go. So the first thing, I remember that we had a project not too long before that, and I learned about the track enable. Hey, we will use the track enable coming off the feedback of the pump. As soon as the pump shuts down, we'll drive it to 0. So you set your track to 0, right? Great. Except for life lesson number 1, you don't want to wake up the operators. So can y'all think what happened? You're rocking along, that pump shuts down, and you slam the line. If you know what a water hammer is, that'll wake up an operator in a hurry, because they think their lines are coming out of the ceiling. So they call me back. Yeah. How to fix this? I got it. Every one of us has been there. Let's use a calc block. So here I put in a quick little calc block. In the calc block, we do our little black magic with the reverse polar notation. Life lesson number 2, technicians do not like calc blocks. If anything ever happens in this loop, ever, whatsoever, and they see a calc block, they're not touching it. They're walking away. So, yeah, exactly. So in the middle of the night, who gets a call? The engineer. I don't like that. So I start toying around and found the switch block. In fact, there was something called the beat time. In fact, it's in more than just the switch block, but one of the best usages for it is when you're taking a value, there is a beat time 1, which is the time that goes from when you're switching from input 1 to from input 2 to input 1, it's going to take that amount of time to switch between them, right? It's going to kind of ramp. So it's not going to be so aggressive. Well, B2 is pretty much the same thing, but it goes from when you're going from input 1 to input 2. Same kind of ramp, right? I was pretty smart and caught, hey, look, this is in minutes. So let's get this thing set up. Get everything set up. You're looking at the controller. All right, you go talk to the operators. The only thing I need to figure out is how long can this valve be open? Does it need to close? And the operator looks at me and says, okay, 10, 15 seconds, that should be fine, right? It's not going to get to your filters any quicker than that, so sure. So we plug in. So let's say 12 divided by 60. Yeah, I can do that in my calculator pretty easily. It's a 0.2, right? Yep. So life lesson number 3. Always read closely and the whole description, because 12 seconds is not equal to 60 seconds, because in the description it tells you the value that you entered is nearly 1/5 of the time that it takes to go from one to the other. Why is that? Because it's a first order filter, right? So if you recall in your Laplace transform in your controls class, 1 times the time constant, you're only at 63%. 2 times you're at 86.5%. 3 times 95%, et cetera, et cetera. So from the time that we started initiating it to the time that the filters plug was less than 60 seconds. So what do? We go ahead and actually change the B time with the realization that, and this is way not only with the B time, but with a lot of the parameters that we deal with being in minutes, and it's a first order. So you take what time you want it to be and you divide it by 5, and that's pretty much the value that you would like to use. So it's 0.04. And anyway, long story short, that was lessons learned. And Sadia, you'd be doing good to remember those life lessons. Every one of y'all has probably already lived it, so I will let you go. But yeah, that was pretty painful, wasn't it? All right, guys, who's next?
many things to plug in. All right. So another quick tip, that's the word of the afternoon, quick tips, quick things that we want to share with you guys. And I'm going to talk first. I'll talk a little with the slideshow and then pull up a VM for a demo. The network view. So this is control editor for the, does anybody not have anything on control editor yet? Okay, so we've got some people, yeah, so this won't mean much to you, but I'll try and cover the basics and maybe beyond the basics. So first we're going to talk about what the network view is and some sort of orchestra concepts that bleed over into our controls, and specifically how that relates to ECBs, because it's not exactly one for one. So the first thing, if you know orchestra, every object in orchestra has two names. It has its tag name and its contained name. This is before Foxborough came into the picture. It's just a concept underlying in the database of orchestra. And I've got a little picture there of, it's actually the FDC 280 demo out there of the network view. So in the network view, it's kind of a cross between like a system definition and your ECBs. It generates your ECBs, but they don't match up one for one 100% of the time. So in our example, we're going to take a look at this E300. It's a device, so an ECB 201 underneath your module, which is your ECB 200. And you'll notice here, I've labeled the E300, that is the contained name. And in other places, you see both names. In the network view, if it's assigned to something, you only see the contained name. There's no tag name inside, right? The other core concept of orchestra to understand is that tag names are global. Two objects in the galaxy can't have the same tag name. That's unique throughout your whole system. For those of you who have used Foxborough before, you know you can have the same ECB with the same name. So there's a little bit of a mismatch there, how those are a little bit different. And in particular, you can't see the tag name here. We'll come back to that. So when you build your network view, it's in the background at the same time creating your ECBs for you. That's what we're all familiar with. If you don't know the shortcut, if you right click on something in the network view, there's an open related ECB that takes you straight to this screen. Little shortcut for you. Quick tip inside a quick tip. So there, as you can see, there's two names here that sort of match up with what we talked about, but not always. There's the ECB name and the dev ID. So I don't know, 80% of the time, we always use the same 6-digit name everywhere, and it's not a problem. But ECB name and dev ID don't always match up with that name you see on the network view. So I couldn't exactly figure out the rule. I was playing around. What I found is for these FDSIs or the FDC 280, I could change the dev ID to be different than the network view, but I could not change the ECB name. Whereas Real IO, the couple that I tried, it was the other way around. Not sure if there's a reason for that, but all that to say is you've got 4 names here that aren't guaranteed to match. So we've kind of seen a couple situations where this matters. So let me flip over to, and now I get the fun of trying to see my own screen while I'm sharing it with you. And it is not responding. computers. Let's give it a minute. Tell IT I need some more memory to run VMs. Yeah, if I could not work on anything for a little while for them to take my laptop, then it would not be a problem. No response. When I was a co-op, I wrote a program that scanned boxes, and if the scanner didn't respond, it's no response from scanner. So now that's what I think every time my computer freezes. No response from scanner. My VM is not pulling up. All right, I'm going to talk and take drastic measures here. I'm just going to turn it off and try and start it again. So I'll try and explain while this goes on in the background and I restart it. The situation we ran into, if John's still in the room, is I mentioned the hidden tag name. In the network view, when you rename an FBM, it renames the contain name, but not the tag name. And when my VM starts responding, I'll show you that. But so you end up with these FBMs that the name you see doesn't match the tag name, especially if you rename it. Or if you build it from scratch, it still has some default name as the tag name, dev 099 or whatever, which is fine. In normal day-to-day life, you just don't run into problems very often. The situation that John ran into is they added a base plate. So all the 0 base plate numbers became 1 base plate numbers. And he renamed them. He had a co-op rename them. And they all became 11, 12, 13. And then he wanted to add the new FBMs. Well, when he went to go build those new FBMs, it said, hey, this is a duplicate name. You can't do that. And he said, what are you talking about? There is no 0, 1. I'm going to file a formal complaint that my VM's not working. Try one more thing here. So this hidden name, there's a couple situations that I wanted to show you guys. If you rename it and you're trying to bulk generate, it'll just complain and say that's names already used. You're looking at the network view, you're not going to see those names anywhere because it's only showing you the contain name. You can, if you know where you are, you can right click and properties and see that tag name. So that's kind of an annoyance. You know, we had to then take those 2 or 3 base plates worth of FBMs. The only way to change that, there's no option to change the tag name while it's assigned. So you have to go unassign it from that FBM or that CP. There's a little folder for unassigned hardware. You have to unassign it, and then it shows up with this hidden name because there is no contain name if it's not assigned. So you rename it there, drag it back. That takes like 10 seconds per FBM, probably if you're fast and your VM works. So per FBM or device, it's not an ECB, David. The network view doesn't have ECBs in it. Per device and per FBM. Yeah, so in John's case, these were hard FBMs, so that's 9 per FBM, the FBM itself, and 8 channels. Well, I said, John, remember, if you know what you're doing. So that's, I say as I can't get my VM to open. Yeah, the network view is pretty slow. So 10 seconds is probably optimistic. It probably took 10 seconds in my VM when it worked because there's 3 FVMs in the whole system. So I'll do my best to paint the scene for you since I can't show you. The biggest thing there is just to be aware that that extra tag name is out there. Right-click properties, you can see it. The thing that we teach to get around that is like the other thing. If you right-click and you're doing a new FVM on your CP, it gets a default name, right? F000, the next number that's available. And if you're a normal person, you right-click and rename there to the actual name, which means you're always going to have an F00097 in your system forever, unless you know to go in and change it. And you'll never see that name until you are doing exporting or importing from somewhere else and names conflict. So as a rule of thumb, we always drag our FVM or our device when we're adding it to unassigned host first, name it there, and then drag it where you want it. It's pretty kludgy. It takes a little bit longer, but you kind of eliminate these problems. And I guess I'll finish up with 2 scenarios where this matters, that things kind of just don't work the way you expect because you don't understand. The example I was going to show is you bulk generate FBM 001. You go in and rename FBM 002, and you go to regenerate a new FBM 001. What it'll actually do then is rename FBM 002 to FBM 001. It renames it back because it still has that tag name, and that tag name is what uniquely identifies it. So everything that, unless you're specifically trying to use the contain name, it's all tag names. The more scary situation that I've run into is we took a backup from somewhere. It was probably Tronox. We'll say it was. And they put some FBMs in the field, and they did it through the GUI, right-click, new FBM. So it became F00045. We also created an F00045 and renamed it in our lab. No big deal. Until we go and we exported those FBMs to import them on site. And it actually moved that FBM that Tronox had built, not us, because we had the same tag name. And it was weird at that point. There was an IOM ID on this CP pointing to an FBM on a totally different CP. So I guess my quick tip is drag it to unassigned, name it there, and move it over. If you care to, you can check for this. There's SQL scripts, but there's no quick way to go back and fix a bunch of them. Like, you know, we were even looking at direct access scripting, and maybe if you had hundreds of them, it would be faster, but you still have to, you know, most of the time with the network view is just waiting for it. It's not a, you unassign, you rename, you move it back. And that takes, you know, back and forth probably takes 20 or 30 seconds per channel, per device or FVM. I'll try one more time before I open up for questions. No, still frozen. Yeah, how about we do that? Everybody take a break and contemplate the meaning of tag names, and I'll try and get my VM working briefly when you guys get back, and we'll move on. That work for you, Dave? Back to our regular scheduled programming. I've got this zoomed in about as much as I can. I'm sure you can barely see it, but hopefully the big shapes at least stick out. So a couple of things I wanted to show, I'll breeze through these since I've already talked about them. First, I'm looking at the network view here. If you go to, oh wow, that's fun, properties, you can see there's two names up here. There's the relative name, if you will, the hierarchical name is what they call it. And here FBM001 is the contained name. In this case, I haven't renamed it yet, so they match. And that's where I generated it here. If I were to rename, you notice rename is grayed out here. Rename contained name is your only option. If I just change that to a 2, numlock 2, says FBM2 there, if you can read that. But if I go to properties here, it says CP2701.FBM2 is the hierarchical name, but FBM001 is still the tag name. So you move on, you forget about that, you never knew it in the first place. But if I come back and I want to generate a bunch of FBMs again, I don't know if I can zoom in here. No, I don't think in general I can't zoom in. But I have this module FBM001, contained name FBM001. So if I want to generate that, rather than creating a new FBM001, they just renamed my FBM002 back. So it just changed the contained name. And then if it was deployed, it would not have done that. That's what John was running into, I think. He had to undeploy and move everything and all the fun stuff. And in particular, you couldn't do this because your problem was the tag name. It's not going to change the tag name. So if I do that and it renamed it there because it's the correct FBM type, if I change this to a 202 and try the same thing, I just get an error. So different type, it just doesn't do anything, which is better, I think, than just renaming with no understanding of what it's doing. So, and then I won't save those changes. The last thing I'll say, I mentioned on unassigned hardware. If I were to take this and move it to that unassigned hardware, it's not contained by anything, so the contained name just goes away. And I can rename it here. And there I'm actually changing the tag name. And drag it back. And for those of you who are lucky enough to be by a TV and can see, here it says FBM002 in both places. And it's fast on my VM. It's not that fast when you have a full system. All right. So I think I have the next 3 quick tips, and they're all about less than a minute each. So we'll blow through them, but they're just kind of little hidden features or nice to know things that you may not notice if you don't know to look for them. I already mentioned right click, open related ECB, takes you to the compound and the ECB's tab, opens that particular ECB. And ID here can't be changed. It comes from the network view, but I can rename my ECB for reason. I go to a strategy. Let me pull up my list. All right. Which team? These in one of these. So, a couple things in a row here. If I open a block, which I don't have yet, it's kind of weird where I zoomed in. I'll do an independent block. So the first thing, obviously, we probably almost everyone in this room learned ICC first. There might be somebody who didn't. But obviously here, you've got these nice names, but they're not what we're used to. So I want a couple kind of nice to know things here that you might not have noticed. First, if I hover over any of these parameters, either the name or the text field, if you can see in the bottom, it gives you a description for all these parameters. It's not the full like block description from the manual, but it can be kind of a nice reminder to if you don't know what parameter it is. And if I hover over any of these value fields, if you can see that, you get a little tooltip. That's the parameter name that we're used to. It went away for a second there, but so this is Boolean N1. That one was pretty obvious. Sometimes it's not as obvious, especially if we get into like mode or something. And then the last, we've done this for a while, but you know, anytime nobody's told you, you probably don't notice this little drop down here in the bottom right. You can click this drop down and it's all your ICC, all your block parameters. So if you don't know what tab they're on, you find it in this list, inhibit opt, and it takes you to it. It's not perfect because it just takes you to the tab and then you're still hunting and it can be hidden. You know, if you were looking for operational text, for example, it would take me here and then it becomes, you know, sometimes it pops up that little arrow. I don't know if that was too quick for anybody to see. I don't know what the rule of thumb is. Sometimes it works, some parameters it doesn't. But we use that all the time because these organizations don't always make sense to me. All right, quick tip number 1, parameter help. Anybody know anything else about that they want to share before I move on? Anybody not know that already? Besides people who don't have control editor? Yeah. Yeah, if you learn ICC first, that's what you're looking for. You don't want message group 1. I have learned that I was saying the parameter name wrong on a lot of parameters because, like, you know, message group 1's not a good example, but like I can't think of any right now, but I've read this and it's like, oh, that's what those 6 letters stood for. That's not what I've been saying for, you know, not as long as Dave. All right, little quick one here. That's kind of weird to show zoomed in. I think Ricker, you were the one. I think you were the one who pointed this out. Let me try and write a line of code here. Is this one working? Check, check, check. I can't hear it. Is it working? Okay. All right. This is what I get for zooming in. I'm trying to write some code, but every keystroke scrolls back up to the top. I'm just going to start typing blind and hope I get it right. All right. So I intentionally mess this up for the 3 people who can read that. I'm leaving off my semicolon. If I compile it, I'll obviously get an error. I thought I would. Ah, What? Yeah. What are you guys talking about debugging sequence code? It doesn't even matter what I write, and it's fine. Yep. Well, if I leave off the E, it'll definitely complain. All right. Test failed successfully. So we get used to that, and that's nice. Sometimes especially if you're using pound defines, in ICC, we get a listings file, sequence w.l, you go in there and figure out what the problem actually is when it doesn't make sense. It's a little bit hidden here. And again, it's quick. You could just right click on that error and say show additional info. And here's your listings file. Just what you're used to seeing. And then you get the full .l file that I did not for several years know was easily accessible. In fact, I think we had John, might have been when he was a co-op, because that's what we do, write a script to go find the file in a hidden directory or something. And we got all this together and we're like, hey, look what we figured out how to do. And Ricker's like, you can just right click and say show additional info. Yeah, so obvious that shows the listing file. Yep. Right click line numbers. You could change your font to something. You could change colors. They do not. Yeah. Yeah, it's funny. It took me to line 73 in a completely different file, essentially. Yep. Compile errors in control editor. Quickest tip yet. I'm going to close this and wrap up our series of quickest tips of the day. Better strategy documentation in control editor. So there's a few things here, and I'm going to open the floor to anything you guys do. It's kind of a general topic, but man, this is kind of hard to do with my resolution. But if I do any smaller, you can't read it. Where'd it go? All right. So I'll start with declarations. We obviously, most of our, 90% of the install base is probably stuff that got converted from ICC, maybe more than 90. So a lot of what I'm going to talk about are things that you don't automatically get in that conversion, and really the value added with control editor, if you will. So the output, connecting strategies, you got an output declaration on one and an input declaration on the other. The standard method is, block underscore param syntax. You connect it, you're done. If you know the compound block and parameter, it makes sense. If you don't, you get to figure it out yourself. So there's this field that is not in ICC, and declarations themselves are not in ICC. If you fill out an output description, you can give it, there probably is a limit. I don't know what it is. It's more than 32 characters. So it's until you get tired of typing, I think. So you can give it a user-friendly description here. I'm not going to try to type anything meaningful here with one hand, but I could give it a description like feed, stock, tank, outlet, discharge, valve, automatic, command, whatever. It could be that detailed, which, block and param name is usually not going to tell you. If I close that, just to show the flip side of that, check it in because it was, and I go to my second strategy, very intuitively named strategy 2. Oh, strategy 1. And what I want to show is that if I get an input declaration, again, not trying to type anything meaningful here because one-handed. Who remembers what CP I'm in? I'm in the compound 001. You'll notice here that I get this kind of grayed out description. So it, when you add an input declaration, it automatically carries that over, connects it, and it's grayed out because that's kind of the default. I can then change it if I want to, but then when I go to use this, I get my description carried along with this. So like, you know, if that's going to calc something, you know, if you have 8 things there, the description can be really helpful to figure out what you're doing. And then I'll just show, I guess, since I said it, I can override that sort of carryover description and add more detail to it here where I've actually linked it. And that just, again, it defaults to the output declaration, what it said, but you can change it everywhere you use it as an input declaration. Yep. Yeah, it was grayed out before. I maybe didn't show that now, or maybe you can't tell, but it's the same color because I typed that in here. It's not just brought. Yep. Yep. Correct. I didn't change it in the source. This is only here that that applies. And then right click, you can potentially hide that description if, you know, if you've got a bunch that description's just in the way. You've got these, we've all seen, I'm sure, all those strategies that, or in this case, it's an input, so it shows the strategy it came from. You could potentially hide that too, especially if it's an output thing that goes to 100 strategies, that can like take up your whole diagram. And then probably last thing on declarations, and then I'll take a quick break to see if anybody else has something. If you don't know, you can right click, you can navigate to, and that'll just take you to the other strategy. I guess I'll do that first. I did not select one, thank you. So that opens that strategy. The other one that's helpful is show connections. Who knows where that's going to pop up with my resolution. It might be off the screen. I don't think so, but maybe this one. We'll see. I'll play your game, Dave. Okay. 1 point for Dave. One point for Unk. Unk 1, medium bro 0. The other thing I'll say, it's kind of a preference. You know, we default to compound block parameter because that makes sense, in all caps and with underscores. When doing something from scratch, I find that, you know, your declaration name can be 32 characters, I think. So, you know, proper case or Pascal case, whatever you want to call it, capitalize the first letter of each word. I like to do that because that reminds me that it's only in the galaxy, right? There's nothing lowercase in the CP. So whenever I see something in all caps, that tells me, hey, this is real. It's a compound name or a block name or a CP name or something that actually makes it to the CP. Whereas all my declarations and my strategy names, I always use proper case. You don't need the underscores. It separates the words with capitalization. Nice thing to have. All right, wrapping up the day. One more topic here about documenting. And in case any of you didn't notice, this is Visio that they've used, which is fine. The green blobs are not great. There's a lot of issues I have with it. But one thing that I think is underutilized is you can still add whatever shapes or text you want onto your strategy diagram. A few cases we've done this in the past is like, say you have a pack-in block that's reading a bunch of bits from a drive or a PLC or something. You could just put a little box in here that's B32 equals drive faulted, for example. And I'm not going to make you guys suffer through me typing one-handed up here, but B31 equals whatever. You can list it all out like that, and I don't know how I managed to rotate like that. That's fun. I somehow tied that to the line. Anyway, so these sort of text box, you can put a border around it, put it next to your actual block to add some extra information. The other thing I've seen is people put like the drawing number in there potentially. Dave, can you think of anything else besides?
Link in there, you go back into a file on the drive.
Yep, if your engineering workstation can get to those documents on a drive somewhere, you can actually link that PNID or loop sheet. Yep. Yeah. You could. Any other things you guys, has anybody done any extra documentation on their strategies other than getting it on there in a way you don't have too many lines crossing? Yeah, you can yep, you can add user attributes on here. I'm definitely not trying that one-handed, but you can.
In the site-specific copy, we added two parameters, G1 and G2, which are essentially descriptions that are a whole lot wider than what you can see inside of the saw.
Yep. Yes, let me repeat that and demonstrate that. So first, again, tangent here, quick tip. If you read the Foxborough manual, it tells you should create a derived template for all the blocks you use. And that's not super common. Some people do that. Foxborough does that when they do a conversion. And there are reasons for that. The big one being, for me, the biggest one being, if you go to a RIN block, where's Dave? If you go to its default appearance object, you drag in a REN block, you'll notice the mesh is not on there anywhere. The one parameter you care about is not on there. So you can modify the base $REN template, but if you create, and I like to use just B underscore, so it's not, you know, I think Foxborough will either do Fox underscore or department underscore, and it ends up being like 10 characters. I like to just B underscore REN as my, for every block I use. And you can change, you can click edit here and change what parameters are on there by default. I'll usually add the parameters that are more likely to be used and make it wider so that a description actually shows up. We can do this. This is a REN block. So I can do that, get rid of this val status parameter that I've never, I won't say I've never used it, but it's rare. And I can try to zoom out. And I'll add description down here on the bottom. All right, so I've updated my default appearance object. I can save and close it. I didn't show the adding parameters there. That's what Ricker was talking about. You can add to that template user attributes, which are not block parameters. They're just something you can fill in with whatever you want. And then you can show those on your strategy. I'll finish showing the REN block. I was talking about you, Dave. You can drag in your B REN that's now something usable, and you don't have to add the mesh parameter every time you want to drag in your REN block. But yeah, user attributes are something you can script in or fill out with bulk generation. That way you can do it all in a spreadsheet. And oh, I didn't know they were in Grid Editor too. So you can edit them all in Excel format that way, and they'll populate. You can add them to your strategy diagrams that way. I've never had an issue with it, so it must update it in the background. All right. Anybody else? I usually do that for description too. Usually whatever I put on this left side. That gets lost if you drag it off to add a parameter and drag it back. It loses the justification, but you know. Yeah, I hate that too. You can do it globally, but for every other parameter, I want the parameter name. Yeah, I don't think there's a way to just show to the description and show the parameter name for everything else. Time is it? I can. I think that's one of the calc blocks are the best thing about Control Editor. But I think we are pretty much out of time. I told Dave I'd give him 5 minutes. Anybody else have strategy stuff or things that they've done with Control Editor that, you know, I'll take anything that's better than ICC. It's not a huge list, but it is a list. I think calc blocks are a whole topic. We've done it a few years ago, I think. Maybe even John, did you do that topic a couple of years ago? Yeah. Yep. All right, Dave, you want to come up and close us out? Anybody else got something on their chest they want to get off and confess before the users group? If anybody would like to convert from another users group, you can come on up to the pulpit and we'll take care of that. Bedard will play some music for us. Gotcha. No, I'm not. What did I do that for? How about we stick with this? What's the time? All right, how about this? Who's got a better, you might be an unk if joke? You might be an unk if. Has anybody seen this? Has everybody seen this? This is what AI was meant for. Dave made that joke Wednesday morning. 10 minutes later, I had this PowerPoint put together with like 12 you might be an unk if jokes. It might be an unk if you get up in front of the users group with the Sun mouse pad. Do you like it better? Is it a better mouse pad than whatever crap they put out today? It's more secure. Yeah. They don't make them like they used to. Yeah, the pulling out the. So this 3D printer, print the save icon, that's not a joke. One of our co-ops asked who printed the save icon. What's that? Fix what? Who said that? Somebody said that in our office. You don't think they thought that? You did this today, Dave. I noticed. I laughed a little. You were talking about the FPM 232 on the node bus. Has anybody got a case of them? We got fishing tackle boxes full of them. Let me tell you, if you don't open those for a couple years and you open them, there's something about the plastic degrading, it just smells horrible. Like it'll empty a room. I was there and I left the room. Me and everyone else in the room left. So by definition, it emptied the room. System Foxray system advisor, system auditor, system analyst. My favorite is Arley's. Did you say system auditor or system monitor? Monitor or auditor? M is in Nancy. That's another Arleyism. Oh, printed. I see. That's what you want me to fix. Well, if I use this presentation, I'll definitely ask ChatGPT to check for spelling errors and grammar errors.
Yeah.
You guys don't carry around a trackball mouse with you?
You got Harley saying Foxray.
Yeah, you might be an unk if you call it Foxray and refuse to call it anything else. Yeah. Absolutely, as long as it's nice.
Well, most of you guys, or a lot of you guys know who I am, but I am not Christian. I am Ryan Causey. I'm based in Birmingham, and so I cover a lot of you guys' dirt, and a lot of you guys are my customers, even though I'm newly transitioned to some of y'all. But I just wanted to thank you guys for coming. I think this is a great event. EOSIS, I think you did a great job. You guys nailed it, you know, with the venue. It was great. The entertainment was great last night. And so just wanted to kind of say thank you for that. And then come on up there. And so I was just kind of saying thank you for the event. And so one of the things I know we wanted to make sure is you felt heard, right? There was some things around the FTSI, the things that were bound where we're going in the future, right? We wanted to make sure that you felt heard, and we presented that, right? That's the idea. And so I hope that was felt today and this week, and just feel free to reach out to each one of us, you know, for if there's questions or issues that we need to address. But Thad?
What were you waiting for me for now? Okay. Any last minute questions or comments? Darren?
Yesterday we talked about going to leaving the Fox News software, going to the Aviva version.
Right.
And then we talked also about software file automation.
Right.
There's some.
Oh, there's a question about how many steps is it?
Is it mutually exclusive? Should you do both? And those kind of things.
So the answer is right. We try to make it as smooth as possible, but there will be disruptions, as we said. It really depends on an individual situation. So what we would really recommend is to have an individual conversation that looks at the very situation on this very customer. We come prepared with a report, so we know the situation, we know what the customer has installed. Sometimes the plan can be even over multiple years, right? With several phases where we look at what is. So there's no one right answer. That's what I'm saying.
Is it okay to just jump from Foxy now and jump directly to a SDA solution, right? Where we don't have to go to Aviva HMI.
So what we showed to you today, or these 2 days, right? And what we showed to you in the demo is not really a full fledged replacement to what we offer with the Foxpro DCS since 30 years, right? Things like multi-user capability in the editor, online changeability, high availability across the board, no single point of failure. All these things are not existing everywhere. So we are starting now with exposing our users to strategy and vision. And you might have noticed that nothing of all these elements have a price tag on it and a release date, right? This is really more a technological demo, proof of concept, and kind of an ideation of to show you how it works. And this might change over the years, right? So we believe that in, correct me Thad if I'm wrong, but 28, 29 timeframe, we are about ready to serve the DCS use cases with Foxpro SDA. And our market is very conservative. Nobody wants to be the guinea pig, right, that tries it out first. So we can now already start small. We can have an automation expert piece connected to an OPC UA client with an FTC 280 on a current system right now. It's available product. And strategic customers are already using this, and we get feedback from them. And you have seen the reference list, right? It's pretty massive. So there is ways to start, but don't like it's ready now. I need to now start a plan for in 3 months. It's not like that. So best is to find a little corner, start playing with it, familiarize yourselves with it, get a feel for it, get a feel to understand what works, what doesn't work. Eventually you can even contribute to the design. We are trying to also listen to customers' desires if we have beta customers or early users that can influence what we design. And then we'll take it from there. So it's a journey, right? And the journey starts now.
Okay. Any other questions not from Darren?
So we're still on FoxView. Thinking about like the next step, would it make sense to jump to full HMI or just the whatever the new one was demonstrated yesterday?
Yeah, so if you're on FoxView now, this is not the future technology. You have understood this right now, right? However, we are starting currently an initiative to build a better migration path for FoxView to orchestral graphics or industrial graphics. So if you have some degrees of freedom to choose, I would eventually wait, right? We have a current path, but it's not perfect. It's working, but it delivers like 80% of the scope, and you need to fill the gap with 20% with manual work, with some engineering. So things like text substitution, bitmaps, some complex, everything that is scripted, generic scripting, overlay calling with generic variables, all these don't convert. And some customers have used these kind of techniques very heavily to build generic overlays, for example, right? All these will stop working. So you have to redesign them somehow different in Control HMI. And eventually we find ways to avoid that with our new tool that we envision to have in a year or year and a half time frame. And again, like FoxView is not supposed to die anytime soon, right? We intend to keep it alive as long as we possibly can. But the future is built on Aviva HMIs, and Aviva is based on industrial graphics. So the migration from FoxView to something from Aviva is not a matter of if, it's a matter of when, right? If you want to continue using your Foxpro DCS into the future, it has to happen at some point.
Wait.
For now,
that's the short answer.
Wait and stay tuned on upgrades, right? And you know how to reach me. I'm always open.
All right. Thank you. Closing. So I wanted to say a few things, I guess, is so last year in Chattanooga, you know, upon reflection at Chattanooga, I was like, wow, what a great event Chattanooga was. So, and it was like, it went off great. You know, you could notice some marketing activities. So last year was a great job. So my expectations were really high for Nashville for this year for this event, and we really appreciate the invite. We appreciate being involved, all the discussion. Every question that we get, we appreciate. but I think we just need a round of applause for the marketing team that put this together, because this was way above expectations. So thank you very much. Thank you. A great job. Very good job. Yep, very good job. And did Dave tell you I got the GDev block working in the FDC 280 over lunchtime? All right. Thank you. I hope to see you all in San Antonio. You should also have a hand signed invitation from myself in August. I don't think it'll be as cold then, but I hope to see you in San Antonio, and safe travels wherever you're going. Yeah.
Thank you.
All right. Thank you, everybody. Feel free to reach out to us. Be sure to get on the email list if you're not. Share that with other people that don't know about it. And we'll keep this thing going. Thank you very much. Oh, yeah. And the survey, don't forget your survey. There's a QR code on the agenda, I think. So if you have your little agenda, you can just hit the QR code on that and answer any questions we might have.